Welcome all. In this session, I'll be discussing GATE XE 2025 Thermodynamics question paper. So there are 22 questions in this video. So all 22 questions I'll discuss in a detailed manner. So how does this help you? ये आपको कैसा help करेगा? Those who are appearing for GATE 2026, so it will be something like complete revision of thermodynamics. So it will help you in mechanical engineering. It will also help you in XC thermodynamics. So wherever concepts are required, I'll be touching the surrounding concepts also, so that it will be the thermodynamics subject will be revised properly. Without wasting time, let us start these 22 questions. Okay, so the advantage of this session is like it will revise our applications of thermodynamics like refrigeration, air conditioning, VC cycle, then psychrometry, then applications of various cycles like Rankine cycle, Otto cycle, diesel cycle, okay, Brayton cycle. Apart from that, complete thermodynamics will also be revised. So without wasting time, let us start. Okay, chalo. Let's take the first question, my dear students. Let's take the first question. Okay. Right. A tank is divided into two compartments with one compartment and one more thing. So I'll give you some associated concepts so that you will have some edge. It is not just doing questions, but concepts will also be revised. Okay, chalo. A tank is divided into two components with one component containing gas at a pressure, some pressure P, while the second is completely evacuated. Means on the other side it is evacuated, there is complete vacuum. If the partition is removed and the gas occupies the entire compartment, which of the following is true? Very good. Now, actually, it is like this, my dear students. There is a container, okay, and it is divided into two parts. Okay, one side there is a gas at a pressure P, and other side it is vacuum. Okay, now if I remove this partition, what will happen? Initially, the gas is occupying a volume V1, let us say. If the partition is removed, and you know, there is no material medium on this side. When there is no material medium, there is no resistance for the expansion of this gas. So it is unrestrained or free expansion. So if I remove this gas will finally occupy this complete position. Means the volume of the gas is increasing and the pressure is decreasing. Let V2 be the final volume. Very good. And you know, my dear students, it is a free expansion. You know that in free expansion, the work transfer is zero. Because for work transfer to take place, work transfer होने के लिए कुछ ना कुछ resistance होना चाहिए. For example, मैं इसको उठाता हूं, so definitely it is offering some resistance, so therefore I have to do some work. Similarly, if I lift heavy weight, I have to do more work. If the resistance is more, work is more. If the resistance is less, work is less. If the resistance is zero, work is zero. Suppose I lift this small paper, how much work I am doing? Zero. Almost negligible, I would say, compared to this lifting of this. So therefore, as there is no resistance, so external resistance is zero, therefore the work transfer is zero in free expansion. Okay, no problem. So let us see what are these giving. And you know, the difference between this pressure is high and this is zero, absolutely zero. So as the difference is very high, the process will be so fast, itna rapid, violently it expands. Matlab, when you close your eyes and open, tab tak process khatam hi ho jayega. Means it is not giving any information about the intermediate points. So it is a rapid process. So whenever the process is very rapid and you are not in a position to find equilibrium points, it will be irreversible. So free expansion is irreversible. Very good. Now, let's see the first option. The work done is equal to area under the curve on PV diagram. My dear students, if it is a closed system and if you are calculating the work under this curve, area under this curve will be equal to work only when the process is reversible. So in this case, as the process is irreversible, the work done is equal to area under the curve. Always remember, for irreversible process, the area under the curve, it will not give you the work transfer. In fact, in this case, the work transfer is zero. इसमें तो work zero ही है, क्योंकि free expansion में work zero होता है. तो the first option is absolutely wrong. The work is equal to area. Leave it. The expansion is not restrained by external force. Exactly. There is no external force. Therefore, expansion is not restrained means it is a free expansion. Absolutely correct. The entire process is reversible. 100% wrong. The overall change in the volume is zero. No. Initially, it has some volume. Finally, the volume is more. Therefore, there is a change in volume. ये भी गलत है. So, the correct option is B, my dear students. The correct option is B. Now, we'll go to the next question. Now, take this question. A cylinder of volume 0.1 meter cube is filled with nitrogen at 100 megapascal and 300 Kelvin. 100 megapascal, sorry, 10 megapascal, 300. Consider nitrogen to be, this is the catchword. This is the catchword. Consider nitrogen to be ideal gas. The cylinder develops a leak and nitrogen escapes into atmosphere and the atmospheric pressure is 0.1. After some time, the pressure in the cylinder reduces to 5 megapascal. Means there is a container, tank. Of course, whenever he says tank, it is a rigid tank. The volume of the tank remains constant. ये याद रख लेना. Now, in the tank, there is nitrogen gas, which we are supposed to take it as an ideal gas. वो बोला भी है यहाँ पे. So, 10 megapascal is the pressure, 10 megapascal is the pressure of the gas and the temperature is 300 Kelvin. And now, वो क्या कर रहा है कि वहां पे एक लीक डेवलप हुआ एंड नाइट्रोजन इज एस्केपिंग फ्रॉम द कंटेनर. तो कहां जा रहा है वो? एटमॉस्फेयर पे जा रहा है. तो जब वो एटमॉस्फेयर जा रहा है तो प्रेशर रिलीज होगा सिलेंडर के अंदर. सो इनिशियली द प्रेशर वाज 10, नाउ फाइनली द प्रेशर इज 5 मेगापास्कल. वेयर इज दैट नाइट्रोजन गोइंग? इट इज गोइंग टू एटमॉस्फेयर. सवाल ये है, अज्यूमिंग द सिलेंडर एंड लिक्विड टैंक लिक्विड गैस टेम्परेचर रिमेन्स कांस्टेंट. मतलब टेम्परेचर क्या बोला है? कांस्टेंट बोला है. किसका? जो गैस जा रहा है और वो सिलेंडर का टेम्परेचर कांस्टेंट, दैट इज आल्सो इक्वल टू एटमॉस्फेयर. एंड व्हाट इज द एटमॉस्फेरिक टेम्परेचर? 300. Now what is the question? The question is, what is the work done by nitrogen in megapascal? ये बहुत ही प्यारा सा क्वेश्चन है सर. इसको थोड़ा हम कॉन्सेप्चुअली पढ़ने की कोशिश करेंगे. ठीक है सर. ओके, लीव इट. देखो क्या करेंगे सर, ध्यान से सुनो. एक सेकंड प्लीज. दिस इज द कंटेनर. एक सेकंड. टूल्स नहीं लेंगे. एक सेकंड. हाँ जी सर. देर इज अ कंटेनर. ठीक है. ओके. इन दैट कंटेनर we have nitrogen at 10 megapascal and the temperature is 300 Kelvin. ठीक है सर. Okay. Now, a leak is developed and the nitrogen is escaping and the final pressure is, my dear students, एक बार देखो तो final pressure कहाँ है? We'll take shapes ले लेंगे, कोई बात नहीं. Now, yes, the final pressure is 5 megapascal and still the temperature is given as 300 and the surroundings or the ambient is also at 300. This is 300 Kelvin. The ambient is at 300 Kelvin. तो जब नाइट्रोजन जा रहा है डेफिनेटली वो क्या करेगा? एक बार देखो, कभी भी याद रख लेना, ऑलवेज रिमेंबर, वर्क ट्रांसफर होने के लिए देयर हैज टू बी रेजिस्टेंस. मुझे बताइए, व्हेन द नाइट्रोजन इज गोइंग आउट, who is offering resistance to the nitrogen? मतलब surrounding atmosphere है, the atmosphere is offering resistance. That's why जो atmosphere को displace होने में जो काम चल रहा है, nitrogen is displacing atmosphere. Whatever the work is done in displacing the atmosphere, that is the work done by nitrogen. चलो देखते हैं सर. लेकिन यहां पे एक छोटा सा प्रॉब्लम है सर. Let us assume that, let us find out the initial mass. Okay, what is the initial mass? Nitrogen is ideal gas, तो PV is equal to MRT, M is equal to PV by RT. So what is the, and one more thing, this whenever the इस pressure को हम किलो पास्कल में ले लेंगे सर, कोई बात नहीं. And I think volume is also given. Let's see what is the volume given. The volume is given as 0.1. The volume is given as 0.1. देखो, the volume of the container is not changing. तो एक बार pressure is 10 megapascal. Megapascal को आप किलो पास्कल में convert करना. So I multiply with 1000. So V volume is 0.1 by R I say रख दो and initial temperature is 300. So the initial mass of the nitrogen in the container is, तो ये 10.1 से गया तो ये दो zeros गए. So initial mass is 10 by 3R. Excellent. Now let's calculate the final mass. The final mass will be equal to PV by again RT. The final pressure is 5 megapascal. I'm sorry, ये 5 है sir. एक second. Let me erase this. हाँ जी. 5 and volume is 0.1, लेकिन ये मेगा में है तो किलो में कन्वर्ट करने के लिए 1000 by R and the temperature is not changing, it is 300. तो ध्यान से सुनो, 0.1 एक जीरो गया, 100 दो जीरोस गए, so it will be the final mass is 5 by 3R. Excellent sirs. The final mass is 5 by 3R. Okay, now how much mass has escaped? Initially in the container, the mass was 10 by 3R and finally in the container it is 5 by 3R. So mass leaving the container, mass leaving is equal to M2 minus M1, M1 minus M2, that is 10 by 3R minus 5 by 3R and that is equal to 5 by 3R. अब ध्यान से सुनो, अब इतना मास गया है, so from the container that much mass has gone. अब ये बताओ मुझे, what will be the pressure of that mass which left the container? Finally it is in equilibrium with atmosphere. पूरा atmosphere को displace करके वो pressure equilibrium में आएगा. So finally this mass will reach atmospheric pressure and already he said it is the temperature is constant. तो हम ऐसा करेंगे कि इस mass को atmospheric condition में लाने के लिए कितना volume occupy करना होगा? Let me repeat sir. For this mass to occupy the atmospheric conditions, what is the volume? Let me repeat. तो ध्यान से सुनो, ये पूरा mass बाहर जा रहा है, तो when it is going out, what will be the pressure of this mass? It will be atmospheric. The atmospheric pressure is 0.1 megapascal, which is equal to 100 kilopascal. नया सेटअप है, थोड़ा प्रॉब्लम हो रहा है सर, करेंगे इसको, सब करेंगे, डोंट वरी. हाँ हाँ, and the temperature is 300. Okay, and what is the mass? What is the mass? This much mass. This much mass, 5 by 3R. Finally, this mass is occupying this. Occupying. Let us say the volume is V0. मान लो इसका volume V0 है. तो finally it is occupying. It is at a pressure of 100 kilopascal temperature. तो एक काम करते हैं. तो ये mass बाहर जाने के बाद कितना volume occupy कर रहा है एक बार चेक करेंगे. Now you may be wondering ऐसा क्यों कर रहा है? I'll let you know everything. तो PV is equal to MRT. So V is equal to MRT by P. Excellent, sir. Mass is 5 by 3R into R and the temperature is 300 and the pressure is 100 kilopascal. So ये गया, RR गया, 3 गया, 5 meter cube. So the final volume is, my dear students, the final volume is what do you mean by final volume? The volume occupied by the nitrogen which is going to atmosphere. अब beauty बताऊंगा sir. Imagine this is the nitrogen initially which is at 10 megapascal and ये पूरा atmosphere था सर, ये पूरा atmospheric air, ये पूरा atmospheric air, जैसे ये बाहर जाएगा ये atmospheric air को displace कर रहा है ये. So ध्यान से सुनो, at a constant this atmosphere is offering the resistance. तो उस constant pressure atmospheric pressure पे तो वर्क क्या हो रहा है सर? नाइट्रोजन किस पे वर्क कर रहा है? नाइट्रोजन is doing on atmosphere. So atmospheric pressure, the air is displaced at atmospheric conditions. So constant pressure work is what? P into P naught into change in volume. तो आप बोलेंगे सर ये तो रिवर्सिबल के लिए PdV ना. I have explained very clearly in class, for a constant pressure process, the work transfer is pressure into change in volume, whether it is reversible or irreversible. But ये भी बोला, अगर reversible होता है तो वर्क ज्यादा मिलता है, अगर expansion है, तो अगर irreversible है तो कम मिलता है. But the equation is same. I have derived also. Okay, this is the equation. So what is the change in volume? Originally यहाँ पे कोई वॉल्यूम नहीं था, तो ये एस्केप होने के बाद ये पूरा इतना वॉल्यूम ऑक्यूपाई कर रहा है. दिस कंप्लीट वॉल्यूम इज 5 मीटर क्यूब. सो व्हाट इज द चेंज? Finally is 5, initially is 0. So therefore initially it is something like a thin membrane. जैसे ही बाहर आ गया पूरा 5 मीटर क्यूब ऑक्यूपाई किया, तो कांस्टेंट एटमॉस्फेरिक प्रेशर पे उसको डिस्प्लेस कर रहा है. तो व्हाट इज द वर्क? The atmospheric pressure is 0.1 mega pascal, means mega newton per meter square, and the volume is 5 meter cube. So ये कट गया. So it is 0.1 into 5. It is 0.1 mega joule is the answer. It's a very good question. तो याद रखना वर्क के लिए what is the resistance? First you catch resistance. जितना resistance है, to overcome that resistance we have to do work. That's it. Okay? चलो. Now we'll move. So 0.5 is the right answer. एक बार आंसर देखते हैं सर. Yes, C is the right answer. Now we'll go to the next one. ये करो. Make it fast. Let's not waste time. Okay. A closed system undergoes a process 1 to 2. अरे यार नया सिस्टम है, थोड़ा दिक्कत हो रहा है सर. 1 to 2. So in 1 to 2, it absorbs 150 kilojoule of energy as heat. So heat it is absorbing means heat supply is positive. So Q12 is equal to how much heat is absorbed? 90. Sorry, it absorbs 150. I'm really sorry. It is 150. So it is 150. ठीक है sir. 150. It is plus because it is absorbing. Now, what is the work done, sir? And does it is doing work means positive. The work in 1 to 2 is 90. Okay. Then it follows another process 2 to 3 in which 80 kilojoule of work is done on it during 2 to 3. 80 kilojoule of work is done on it. So therefore, when the work is done on it, it is negative and it rejects 60 kilojoule of heat. So Q23 is equal to minus 60 kilojoule. Why minus 60? Because it is rejecting. Excellent. Now, it is designed to restore the system to the initial state. What do you mean by initial state? 1 to 2 is one process, 2 to 3 is another process. Now the system is at state 3. So we have to bring it back to the original state means 3-1. So 3-1 is the original state. Okay. By an adiabatic path. It means 3 to 1 is an adiabatic path. So what is the heat transfer in 3 to 1? It is adiabatic. So therefore it is 0. Now what is he asking? Then the work interaction in the process is, देखो, he is asking work 3-1. तो कैसे करेंगे सर? बहुत सिंपल है. The first law of thermodynamics for a cycle says sigma q is equal to sigma w. That is net heat transfer in a cycle is equal to net work transfer. Okay. So sigma q is Q12 plus Q23 plus Q31. That should be equal to sigma W. That is W12 plus W23 plus W31. So what is Q12? It is 150. What is Q23? It is minus 60. What is Q31? 0. What is W12? 90. What is W23? Minus 80. And what is W31? We are supposed to find out. Correct, sir? Yes. अब देखो 150 minus 60 is 90. This 90 is gone. तो यहाँ पे 0 है. तो minus 80 इधर आएगा. So W31 is equal to plus 80. Means work is done by the system in 3 to 1 process and it is 80. जो भी unit है, kilojoule है तो kilojoule है. So answer is A. Good. Now let's move to the next question. आइए पढ़ो sir. Come on, make it fast. Let's not waste time. It is a flow process, means open system. And he is asking maximum power. What does maximum power mean? Maximum work. Okay, maximum work. So you know very well, for a closed system, maximum work is equal to change in Helmholtz function. U1 minus U2. F1 minus F2. And for open system, the maximum work is change in Gibbs energy. So Gibbs function. Okay. So answer बताओ sir. It is rate of decrease of Gibbs free energy. So therefore the maximum power ये flow है open है तो it is change in Gibbs function. Okay. चलो. Next. हाँ. If gamma refers to the ratio of specific heat, the air standard efficiency of Otto cycle. याद रखना, Otto cycle is also known as constant volume cycle because in Otto cycle heat is supplied and rejected at constant volume process. And in Otto cycle the efficiency is given by, I don't know why he is so much interested in Otto cycle. The efficiency of Otto cycle is given by 1 minus 1 by R is the compression ratio, R power gamma minus 1. Is this correct? 1 minus 1 by R power gamma minus 1. 1 minus 1 by R power gamma minus 1. So the answer to this is what? बिल्कुल sir, बोलो. What is the answer? मित्रों, कहाँ गए रे आप लोग? Do you want me to derive? 1 minus 1 by R power gamma minus 1. So therefore, this is question number 5. Correct? No problem at all. So 1 minus 1 by R power gamma minus 1, where R is compression ratio. What is compression ratio? Volume before compression to the volume after compression. For example, let me show you very clearly on PV diagram. So isentropic compression, constant volume heat addition, isentropic expansion, constant volume heat rejection. So this is our Otto cycle. So 1, 2, 3, 4. Here heat is supplied. It is expansion and this is heat rejection. So therefore volume before compression to the volume after compression, इसको बोलते हैं compression ratio. Is it okay? Is it okay? Next. 1 minus 1 by r power gamma minus 1. Yes, it's a simple question. तो इसमें बहुत सारे क्वेश्चंस आते हैं सर, थोड़ा केयरफुल रहो. नेक्स्ट, ओके, नाउ if TL and TH denote TH and TL denote the absolute means in Kelvin high and low temperatures of the reservoirs. The coefficient of performance of a reversible refrigerator means it is a reverse Carnot cycle. For a Carnot cycle, the COP depends only on temperatures. So the COP of a reversible cycle, which is reverse Carnot cycle, is given by a Carnot है, reversible refrigerator है, so it will be T lower by T higher minus T lower. Excellent sir. Okay, तो बट आंसर न्यूमरेटर में 1 है सर. अगर न्यूमरेटर में 1 चाहिए, जस्ट इसको इंप्रोवाइज कर देना, मैनिपुलेट कर देना. तो क्या कैसा 1 आएगा सर? अगर मैं TL बाहर लेता हूं, इफ आई टेक TL आउट, इट विल बी TH by TL minus 1, तो ये कट जाएगा. सो इट विल बी 1 by TH by TL minus 1. सो देयरफॉर कहां है रे? 1 by TH by TL minus 1. Yes, the answer for this is A is the right option. Okay, चलो नेक्स्ट. हाँ, ये करो. Good question, sir. Please read the question. Let's not waste time. Please read the question. A tank, whenever he says tank, volume is fixed. याद रख लेना. So it's not elastic, it is a rigid tank. Okay, right. A tank of 4 meter cube contains an ideal gas. Oh, it's a question on mixture of gases. 60% nitrogen and 40% 60% hydrogen and 40% nitrogen by volume. एक बात बताना चाह रहा हूं सर. We can treat nitrogen, hydrogen, argon, air, carbon dioxide as an ideal gas. तो याद रखना, for an ideal gas, the the composition volume. The composition by volume is also proportional to volume is proportional to number of moles as per Avogadro law. As per Avogadro law, the volume, अगर ideal gas नहीं है तो हम अप्लाई नहीं कर सकते सर. ये ऑलरेडी ideal gas है. Volume is directly proportional to number of moles. ठीक है सर. तो volume ratio is also equal to moles ratio. Mole ratio is nothing but mole fraction. ये याद रख लेना सर. Already I have explained in class. चलो कोई बात नहीं. हाँ, by volume. देखो, the pressure is 100 kilopascal and the temperature is 100. याद देखो, hydrogen is 60% and nitrogen is 40% and the volume is this is the volume ratio. In terms of volume ratio given, volume share is given. Okay, nitrogen is added to the tank such that the composition changes to 50% nitrogen by volume with the final temperature again at same. The amount of nitrogen, देखो, he is asking nitrogen in number of moles to be added and it is NAT question. इसको थोड़ा अच्छा कर लेंगे सर. मैं आपको सिंपल वे में एक्सप्लेन करूंगा सर. आई विल एक्सप्लेन इन अ वेरी सिंपल वे. देखो, अरे नया सेटअप है, थोड़ा दिक्कत हो रहा है, खींच रहा है वो. चलो कोई नहीं. हाँ, देखो, देयर इज अ कंटेनर. ठीक है सर. दिस कंटेनर कंटेन्स हाइड्रोजन एंड नाइट्रोजन. What is the volume fraction of hydrogen? 60% hydrogen, 40% nitrogen. 60% hydrogen means 0.6 volume basis में and 0.4 is nitrogen. Okay, and what is the pressure, sir? The pressure is 100 and the temperature is 300. Pressure is यहां पे लिखेंगे. Pressure is 100. Is it kilopascal? Yes, and the temperature is 300. ठीक है सर जी. My dear students, it is the volume fraction. So for an ideal gas, volume fraction is also equal to mole fraction. So इसीलिए, because number of the volume occupied is proportional to number of moles as per Avogadro law. So therefore, this I can write directly as X of hydrogen. I'm sorry, this is not क्या बोलते हैं, एक सेकंड. This is hydrogen and that is equal to 0.6 and this is X of nitrogen and that is equal to 0.4. कोई बात नहीं सर, absolutely fine. अब सुनो carefully. You also know one thing clearly. The partial pressure. If I want the partial pressure, it will be mole fraction into total pressure. This is wonderful. I have derived this equation also. So this is the total pressure of the gas of the mixture. If I want the partial pressure of hydrogen, it will be mole fraction of hydrogen into the total pressure. So the partial pressure of hydrogen is equal to, what is the mole fraction of hydrogen? 0.6. And what is the total pressure? 100. So therefore, the partial pressure of hydrogen is equal to 60 kilopascal. Absolutely fine. Similarly, the partial pressure of nitrogen will be equal to, very simple, the total is, according to Dalton's law of partial pressure, total pressure is sum of the partial pressure. Total is already 100, hydrogen is 60, so nitrogen will be 100 minus 60, or you can also write P2 is equal to X2P. So X2 is 0.4, 0.4 into 100 is 40. Okay. So you may be wondering, sir, how does it help us? ये मुझे कैसा फायदा मिलता है? मुझे बताइए सर. Second case में what are we doing, you know? Actually, this is the case one. So we are adding nitrogen. Is the volume of the tank changing? No. Okay. And finally, he also said that the final temperature क्या है? एक बार देखो sir. What is the final temperature? The final temperature is 300 Kelvin. No problem at all. देखो, you are adding nitrogen. So definitely the volume fraction of nitrogen will increase, and therefore, and the mole fraction of nitrogen will also increase. And finally, he said the nitrogen is added such that the final volume fraction of nitrogen is क्या बोलते हैं 50%. चलो देखो कैसे करेंगे सर. The technique is, are the number of moles of hydrogen changing? No. हाइड्रोजन के नंबर ऑफ मोल्स चेंज नहीं हो रहा है. तो ऐसा करेंगे हम, we'll calculate the number of moles of hydrogen and go to the next one, because in the next one you are just adding hydrogen but you are not changing nitrogen. You are adding nitrogen, you are not changing hydrogen. So whatever the hydrogen moles are obtained here, I'll be using same here to calculate some other parameters. चलो कोई बात नहीं. तो you know very well the answer is asked in number of moles. तो क्या करेंगे सर? PV is equal to NR bar T. So let me apply this equation to hydrogen. So it will be partial pressure of hydrogen, don't write volume of hydrogen. Hydrogen is occupying the complete volume, and the temperature of hydrogen or the mixture is same. So volume of the hydrogen or volume of the mixture is same, and the temperature is same. So therefore, P of H2 I do not know. Already I know. I'm sorry. Already I know. What is the P of H2? 60. So 60 यहाँ पे I need some एक second. हाँ, अरे यार ये नया नया है पूरा. P of hydrogen कितना है सर? 60. And what is the volume of the tank? He has given, I think. कहाँ पे दिया है? एक सेकेंड. 4 meter cube. Correct. 4 meter cube. देखो, volume of the tank is 4 meter cube. Number of moles of hydrogen R bar 8.314, and the temperature is 300. So from here, I'll be calculating the number of moles of hydrogen. So the number of moles of, time waste नहीं करेंगे, directly we have ready-made values. एक बार मैं चेक करता हूँ. अरे यार ये अटक गया. Number of moles of hydrogen is कहाँ गए रे वो? 0.096223. एक बार मैं कैलकुलेट करता हूँ. अरे यार ये 240 by 8.314 divided by 300. 0.0, yes, 0.096223 किलोमोल ये नाइट्रोजन का है. वेरी गुड. तो कैन आई कैलकुलेट, ये याद रख लेना सर, दिस इज द नंबर ऑफ मोल्स ऑफ हाइड्रोजन इन दिस. सो कैन आई कैलकुलेट द नंबर ऑफ मोल्स ऑफ नाइट्रोजन? यस, आप बिल्कुल कैलकुलेट कर सकते हैं सर. कैसे? इधर देखो, P ऑफ नाइट्रोजन V is equal to N of nitrogen R bar into T. Don't write V of nitrogen because nitrogen is occupying complete volume and the complete mixture is at the same temperature. Whether it is hydrogen temperature or nitrogen, it is the mixture is at the uniform equilibrium temperature. So what is the partial pressure of nitrogen? 40. And volume 4. It is occupied. Is it 4? Yes. The complete tank volume is 4. Okay. And number of moles of nitrogen into R bar is 8.314 and the temperature is 300. So from here I'll be calculating the number of moles of nitrogen. Let me check up, sir. It is 160 divided by 8.314 divided by 300 and this 0.064. Am I right? एक बार मैं चेक कर लेता हूँ, क्रॉस चेक. 0.0641488. 0.0641488. These are the number of, ये पहले इनिशियल नंबर ऑफ मोल्स ऑफ नाइट्रोजन. अब क्या बोल रहा है? nitrogen is added. So which quantity will remain same? I mean the mass or the number of moles, because hydrogen is same. So therefore अब जाएंगे सेकंड, ये पहले इनिशियली नाइट्रोजन के इतने मोल्स है, अब केस 2 में डेफिनेटली नंबर ऑफ मोल्स ऑफ नाइट्रोजन विल बी मोर देन दिस. ही इज आस्किंग हाउ मेनी मोल्स आर एडेड. तो फाइनल मोल्स कैलकुलेट करेंगे नाइट्रोजन का, और इनिशियल तो हाई है, विल टेक द डिफरेंस, यू विल गेट द आंसर. सो एक सेकंड, विल डू इट. एक बार देखना सर, एक बार देखना. हाँ, okay, the volume is 4. I don't know the pressure. So what is the volume ratio? And you know दोनों का मोल फ्रैक्शन सेम है, अब हाइड्रोजन और नाइट्रोजन, and both are 50%, because the volume is changing to 50%, fraction 50% होगा. Whether it is volume fraction or mole fraction, it will be same if it is an ideal gas. Okay, अब क्या करेंगे सर, एक काम करते हैं. And finally the temperature is also, I don't know the pressure, total pressure, but the temperature is 300. एक काम करते हैं सर, partial pressure of hydrogen V is equal to N of hydrogen R bar into T. Why are you using this equation? Because already I know the number of moles of hydrogen, whether it is initial case or final case. We are not adding hydrogen, we are adding nitrogen. So number of moles of hydrogen will remain same. तो पहले जो कैलकुलेट किए वही रहेगा. So let us calculate the partial pressure of hydrogen. एक बार partial pressure hydrogen आ गया, I can easily calculate from the mole fractions. I can calculate the total pressure. कैसे? इधर देखो sir. What is the partial pressure of hydrogen? So I do not know. And volume is 4 meter cube. Number of moles of hydrogen already we have calculated. वो तो change नहीं हो रहा है. 0.096223. 0.096223. R bar 8.314, and the temperature is 300. So what is the value of partial pressure of hydrogen? I think you are getting this as, एक second मैं check करता हूँ. 8.3. This is coming out to be 60 kilopascal. Excellent, sir. And you know the total pressure, the partial pressure of hydrogen is equal to mole fraction of hydrogen into total pressure. So the partial pressure of hydrogen is 60. The mole fraction of hydrogen is 0.5, and this is the total pressure. So total pressure will be 120. If the total pressure is 120, hydrogen pressure is 60, what will be the partial pressure of nitrogen? So therefore the partial pressure of nitrogen will be equal to the total pressure of partial pressure of hydrogen. So the total pressure is 120 and the partial pressure of hydrogen is 60. So this will be equal to 60. And now you apply. अब हो गया sir. So PV is equal to P volume is N of nitrogen R bar into T. So partial pressure of nitrogen is 60. Volume is 4. Number of moles of nitrogen unknown. R bar is 8.314 and the temperature is 300. यहाँ से I can easily calculate the number of moles of nitrogen. So if you want the number of moles of nitrogen, I think you are getting this as 0.096223. So this is the final number of moles of nitrogen, and already we have initial number of moles of nitrogen 0.0641488. 0.0641488 initially. 0.0641488. So number of moles added will be final minus initial. So therefore, if you take the difference of 0.09623 minus 0.0641488, so you will get the answer as कितना आ रहा है सर? 0.032 kilomole. 0.032 is the final answer. Is it okay? 0.032. Clear? It's a good question, sir. It's a good question. अच्छा क्वेश्चन था. तो एक ही कॉन्सेप्ट है कि वॉल्यूम फ्रैक्शन इज ऑल्सो इक्वल टू मोल फ्रैक्शन फॉर एन आइडियल गैस. Avogadro law. ठीक है. Next. So let me fill the answer. So it is 0.032. I don't know how much range the gate key is released. I don't know exactly. दिखते हैं सर. एक बार होने के बाद एक बार क्रॉस चेक कर लेना सर आंसर्स. A heat engine having a thermal efficiency of 40%. So the efficiency of engine is 0.4. Receives heat from a source. The higher temperature is 600 Kelvin and rejects heat to a sink at the lower temperature is 300 Kelvin. What is the second law efficiency? You know that the second law efficiency is equal to the actual efficiency by ideal efficiency, ideal or reversible or maximum efficiency, ideal or maximum. So actual efficiency is already given. Let us calculate ideal. The ideal or maximum efficiency is given by 1 minus T lower by T higher. You know this. So 1 minus the lower temperature is 300 and higher is 600. So the ideal efficiency is equal to ये half होगा तो 0.5 हो जाएगा sir. So therefore the second law efficiency is equal to the actual efficiency is 0.4, the ideal efficiency is 0.5, so this is equal to 0.8. but ये क्या पूछा, परसेंटेज में पूछा है सर. देखो परसेंटेज में पूछा है, बी केयरफुल, यू मे बी गेटिंग 0.8 but don't substitute here, and especially in numerical ability type you have to be very very careful. So 0.8 का मतलब क्या है, ये 80% हो जाएगा सर. So the answer to this question is 80. So 8th question का आंसर है 80. Is it okay? चलो नेक्स्ट, विदाउट वेस्टिंग टाइम. बहुत बढ़िया चल रहा है सर. हाँ ये करो. A rigid tank of 300 liter capacity. 1 liter is 10 power minus 3 meter cube. So 300 liter is 300 into 10 power minus 3 is 0.3 meter cube. Contains 3 kg of nitrogen. The mass of oxygen, I'm really sorry, 3 kg oxygen, and the molar mass is given 32 gram per mole or kilogram per kilomole, कोई बात नहीं. And the temperature is, whenever oxygen is given ideal gas, put the temperature in Kelvin. 25 degrees centigrade can be written as 298 Kelvin. Add 273. And he clearly said nitrogen is being as an ideal gas. The pressure in the tank is very simple, sir. ये तो ऐसे क्वेश्चंस एक बार आएंगे. एंड वन मोर थिंग सर, व्हेन क्वेश्चंस आर इजी, प्लीज उसको इजी है, दैट्स वाई हल्का सा लेके आप कैलकुलेशन में मिस्टेक्स मत करना, बिकॉज दे आर वेरी डेंजरस क्वेश्चन. सिंपल थिंग्स आर ऑलवेज कॉम्प्लिकेटेड. सो पीवी इज इक्वल टू MRT. तो यहां पे why are you not writing in R bar T? Because the number of moles are not given. Here the mass is given. When mass is given, I'll write this form. When moles are given, P is equal to in R bar T. R bar is universal gas constant. No problem at all. अब देखिए सर, हाँ क्या बोल रहा था? But unfortunately, I don't know R. What is R? Characteristic gas constant. You know, the characteristic gas constant is equal to universal gas constant by molar mass. So therefore, R is equal to 8.314 and molecular mass is 32. So therefore, so many kilojoule per kg per Kelvin. So therefore, एक बार देखो, R bar value is 8.314. Can you tell the unit of R bar? Sometimes R bar का unit भी पूछ सकता है सर. Kilojoule per kilomole per Kelvin. This is the unit. By क्या है सर? By kg पर ये 32 का यूनिट क्या है? kg पर किलोमोल. तो किलोमोल गेट कैंसल, kg पर किलोजूल पर kg पर केल्विन. सो आर का यूनिट. वेरी गुड. तो ही इज आस्किंग, व्हाट इज द आस्किंग सर? प्रेशर पूछा है. सो व्हेनेवर आर इज इन किलोजूल पर kg पर केल्विन, प्रेशर शुड बी इन किलो पास्कल. तो दोबारा बता रहा हूं, आर इज ऑलरेडी इन किलोजूल पर kg पर केल्विन, और तो इसको किलो पास्कल में रखा. P I do not know. What is the volume given? 0.3. The mass is given as 3 kg and R is 8.314 by 32. Temperature should be strictly in Kelvin. From here, I'll get the value of pressure and that will be in kilopascal. तो कितना आ रहा है सर? एक बार देखते हैं. 774 kilopascal. So the answer is 774. Is it okay? चलिए, move to the next. अच्छा चल रहा है सर. हाँ ये करो. An ideal gas turbine cycle. T1 and T3 are compressor inlet and turbine inlet temperatures respectively. Compressor inlet and turbine inlet respectively. The ratio T3 by T1 is denoted by small t. Then the ratio of specific heats is gamma. For any given value of T, the optimum, what do you mean by any given value of T? Means my T3, T1 are fixed. Given का मतलब ये ratio fix है. मेरा T1, T3 fix है. ठीक है. तो what is he asking? The optimum pressure ratio for maximum work output. ये बहुत ही routine question है सर. Every time. क्या पता ये XC, last year it was asked in XC. तो this time it may be asked in mechanical gate. Very simple sir. अब देखो. Let me write. मित्रों, let me draw gas turbine cycle. Gas turbine cycle कैसा है रे? Isentropic compression, constant pressure heat addition, isentropic expansion, constant pressure heat rejection. ठीक है सर. सही है ना सर? बिल्कुल. और if you want on TS diagram, isentropic compression, constant pressure heat addition, then isentropic expansion and constant pressure heat ejection. ठीक है sir, very good. This is the gas turbine cycle on PV and TS diagram. What is fixed here? T1, T3 are fixed. And किस condition? What is the pressure ratio? ये बताओ. Let this pressure be P1, which is also equal to P4. Let this pressure ratio be P2, which is also equal to P3. So what is the pressure ratio, sir? It is the highest pressure by lowest pressure, that is P2 by P1. This can also be written as P3 by P4. ये भी लिख सकते सर. ठीक है. अब देखो. Is the pressure ratio. बहुत बढ़िया. This is the pressure ratio. ठीक है. No problem at all. Now, can I write? देखो, 1 to 2 is reversible adiabatic. So T2 by T1 is equal to P2 by P1 power P2 by P1 power gamma minus 1 by gamma. This because as 1 to 2 is reversible adiabatic, moreover the working fluid is an ideal gas. Whenever three conditions are satisfied, reversible, adiabatic, ideal gas, I can use this equation absolutely fine, no problem at all. So what is P2 by P1? RP, that is pressure ratio. T2 by T1 is RP power gamma minus 1 by gamma. But what is he asking? He is asking the pressure ratio. So what will be RP, sir? If I want the pressure ratio, it will be T2 by T1 power ulta. Or you raise this to gamma by gamma minus 1. It will be 1 gamma by gamma minus 1. Yes, बहुत बढ़िया. But what is he asking? He is asking pressure ratio, my dear students. He is asking the pressure ratio for maximum. He is asking the pressure ratio for maximum work output. How to find out maximum work output? ध्यान से सुनिएगा सर. In the turbine, you are getting work. So the turbine work is, if I apply steady flow energy equation, neglecting kinetic and potential energy changes, the turbine work will be H3 minus H4. And if you want the compressor work, so the compressor work is equal to H2 minus H1. So therefore, the net work is given by turbine minus compressor, that is H3 minus H4 minus H2 minus H1. Okay, fine, no problem. So the net work is given by, let me take Cp bahar, CpT3, because the working fluid is an ideal gas. For an ideal gas, enthalpy can be written as Cpt. So H3 is Cpt3, H4 is Cpt4, so it will be, and H2 is Cpt2, H1 is Cpt1. पूरा Cp को बाहर ले लेना and bracket open करना. If you open the bracket, it will be minus T2, minus of minus plus T1. Absolutely fine. Now, I have already derived one equation in case of Otto cycle and in case of gas turbine cycles, because Otto cycle में heat is supplied at constant volume, heat is rejected at constant volume. Therefore, यहाँ पे भी heat is supplied at constant pressure, heat is rejected at constant pressure. Nature of processes at where the heat is supplied and heat is rejected is same. दोनों में भी ऑटो साइकिल में दोनों कांस्टेंट वॉल्यूम है, यहाँ पे दोनों कांस्टेंट प्रेशर है. When such is the case, then product of odd temperatures is equal to product of even temperatures. ये already I have derived. So you can use that in Otto cycle, you can use here also, but don't use that in diesel cycle. So therefore, I can write the product of odd temperature, and all temperatures are in Kelvin, should be equal to product of even temperatures. ठीक है sir. So this work can be written as, my dear students, Cp into T3 minus T4. What is T4 from this? So T4 can be written as T1 T3 by T2 minus T2 plus T1. Now you know already he says given value of T3 T1. मेरा T1 T3 fix है. तो how can I get maximum work? अगर आपको maximum work चाहिए, you differentiate with variable and equate it to 0. तो करो. So the for maximum work dW net by d, यहाँ पे variable क्या है एक बार देखो. You just see what is the variable. Highest temperature T3 is fixed. Lower temperature T1 is fixed because atmospheric temperature is fixed, and metallurgical condition turbine inlet temperature highest temperature वो भी fix होगा. The only variable is T2. तो T2 के respect से differentiate करना. So therefore Cp, this is constant, तो 0. T1 T3 is constant, and you know, my dear students, what is 1 by T2 differentiation? Minus 1 by T2 is T2 power minus 1. Minus 1 into T2 power minus 1 minus 1. So it is minus 1 by T2 square. Okay. And T2 का 1 है, T1 का 0 है. This should be equal to 0. तो क्या होगा सर? Minus 1 minus plus T1 T3 by T2 square. Minus 1 is 0. So T2 square will be equal to T1 T2. T2 will be equal to root T1 T3. So याद रखना. तो whenever, ध्यान से सुनो सर, whenever the क्या बोलते हैं, the work is maximum, under that condition my T2 and T4 are same. मित्रों, my T2 and T4 are same. Yes. This is 1, this is 2, this is 3, and this is 4. Isentropic compression, constant pressure, heat addition, isentropic expansion, constant pressure. So T2, T4 is same, and that is equal to root T. So T2 is equal to T4 is equal to रूट ऑफ T1 T3. सर एक मिनट, समझ में नहीं आया. आपने तो T2 को रूट T1 T3 डिराइव किया, बट व्हाई आर यू सेइंग T4 इज आल्सो इक्वल टू दिस? इधर देखो, व्हाट इज T4 सर? यहां से T2 विल बी इक्वल टू रूट T1 T3. फ्रॉम हियर T2 इज रूट T1 T3, करेक्ट. बट हाउ इज T4 इक्वल टू रूट T1 T3? इधर देखो, T4 कैन बी रिटन एज T1 T3 बाई T2. व्हाट इज T2? रूट T1 T2, रूट T1 T3. So ये कट जाएगा, again it will be root T1 T3 only. So now put it here. So for the optimum pressure ratio, ये मतलब क्या है सर? ऑप्टिमम प्रेशर रेशियो का मतलब है इट इज वन सच प्रेशर रेशियो वेयर द वर्क आउटपुट इज मैक्सिमम. सो ऑप्टिमम इज इक्वल टू T2. व्हाट इज T2 सर? ऑलरेडी यू नो T2 इज रूट ऑफ T1 T3 बाई T1 पावर गामा बाई गामा माइनस 1. तो ये रूट गया, तो ये रूट गया, तो नीचे रूट आएगा रूट T3 बाई T1. सो T3 बाई T1 रूट का मतलब 1/2, ये 1/2 बाहर आएगा. सो देयरफॉर आरपी ऑप्टिमम इज इक्वल टू T3 बाई T1 को ऑलरेडी क्वेश्चन में दिया है T. अरे यार रूट तो रूट T1 आएगा, रूट T3 बाई T1, रूट T3 बाई T1 इज T पावर 1/2. T3 बाई T1 ही इज टेकिंग इट एज स्मॉल t. वो बोला है T3 बाई T1 इज स्मॉल t, तो स्मॉल t ये पावर 1/2 हो जाएगा, तो इट विल बी गामा बाई ट्वाइस ऑफ गामा माइनस 1. दिस इज द इक्वेशन. सो t पावर गामा बाई 2 टाइम्स गामा माइनस 1. कहां गए रे? t पावर गामा बाई 2 टाइम्स. तो आई थिंक b इज करेक्ट. 10th वाला b इज करेक्ट. करेक्ट 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 करेक्ट. एब्सोल्युटली फाइन. नाउ विल गो टू द नेक्स्ट वन. कहां गए रे? 11th. फॉर अ प्योर सब्सटेंस, दिस इज अ गुड क्वेश्चन सर. ये अच्छा क्वेश्चन है, अच्छा है, मतलब नॉट दैट टफ बट अ गुड क्वेश्चन. ठीक है. फॉर अ प्योर सब्सटेंस दैट एक्सपैंड्स ऑन फ्रीजिंग, कैन यू गिव एन एग्जांपल ऑफ अ सब्सटेंस दैट एक्सपैंड्स ऑन फ्रीजिंग? वाटर. विच ऑफ द फॉलोइंग इज करेक्ट? एक बार देखना सर, एक बार देखना. इसको हम कुछ कर सकते क्या? एक सेकंड. हाँ, ये भी है अपने पास. वाह वाह, सीख रहे, नया बोर्ड, नया सब कुछ सीख रहे. वाह. दिस इज फॉर जनरल सब्सटेंसेस. दिस इज सॉलिड. अरे यार, दिस इज सॉलिड, दिस इज लिक्विड एंड दिस इज वेपर, एंड दिस इज योर ट्रिपल पॉइंट. ये हमारा ट्रिपल पॉइंट है. दिस इज ट्रिपल पॉइंट प्रेशर एंड दिस इज ट्रिपल पॉइंट टेम्परेचर. दिस इज फॉर जनरल सब्सटेंसेस. बट यू नो वेरी वेल ही इज आस्किंग फॉर अ सब्सटेंस विच एक्सपैंड्स ऑन फ्रीजिंग. So which curve will change? It is the fusion curve that changes. It is the fusion curve which, this is the sublimation curve because solid vapor. This is fusion curve solid liquid and this is vaporization curve. यहाँ पे critical point होगा सर, यहाँ पे critical liquid vapor में convert होने का. This is critical point. So this pressure will be critical pressure. This will be critical temperature. ठीक है sir. Now, but this graph is not correct sir. Why? Because he is asking for a substance that expands on freezing. So substance that expands on freezing, इसको कार्डून टाका sir. You remove this. So therefore you have something like this. The graph is something like this. Okay. ठीक है sir. Because for the fusion curve slope is negative on PT diagram. For substances that expand on freezing, ये पूरा solid है. एक बार क्वेश्चन को देख लेते हैं सर. This is solid. This portion, ये पूरा solid है, ये liquid है, वेपर है. सवाल देखो अब क्या है. देखो ऑप्शन ए, द टेम्परेचर ऑफ द लिक्विड फेस कैन बी लोअर देन द टेम्परेचर ऑफ ट्रिपल पॉइंट. वो बोल रहा है लिक्विड फेस का टेम्परेचर ट्रिपल पॉइंट से कम हो सकता है. एक बार देखो ऑप्शन ए देखो, द टेम्परेचर ऑफ द लिक्विड फेस कैन बी लोअर देन द टेम्परेचर ऑफ ट्रिपल पॉइंट. देखो ध्यान से सुनो, कलर चेंज करूं क्या? लेट मी चेंज द कलर. ओके देखो सर, क्या ये लिक्विड है सर? क्या ये लिक्विड है? बिल्कुल लिक्विड है सर. देखो नाउ यू सी द टेम्परेचर ऑफ दिस लिक्विड. Is it lower than ट्रिपल पॉइंट? दिस इज द ट्रिपल पॉइंट टेम्परेचर, दिस इज द ट्रिपल पॉइंट. क्या ट्रिपल पॉइंट से कम है? यस, ये लिक्विड है क्योंकि ये कर्व ऐसा है. अगर ऐसा होता है, had it been like this, it will be greater than ट्रिपल पॉइंट. तो आपको लिक्विड मिलेगा ही नहीं अगर ये ऐसा है तो ट्रिपल पॉइंट के नीचे, ट्रिपल पॉइंट टेम्परेचर के नीचे. बट यहां पे यस, ये एक्चुअली क्यों हो रहा है? बिकॉज ऑफ द डेंसिटी डिफरेंसेस. फिजिकल एक्सप्लेनेशन, I'll explain this in class, but this is occurring due to like cage-like structure and density differences के कारण हो रहा है. So definitely ट्रिपल पॉइंट टेम्परेचर से लिक्विड फेज, ये तो लिक्विड है सर, दिस ऑल लिक्विड. लिक्विड का टेम्परेचर देखो, ये टेम्परेचर और यस ट्रिपल पॉइंट से कम हो सकता है. किसमें? when it contract, when it expands on freezing. तो ये absolutely सही है सर. ऑप्शन ए is correct. The temperature of the liquid phase can be lower than the triple point. बिल्कुल सही है सर, बिल्कुल सही है जी. Okay, okay. Now the critical pressure is equal to pressure at triple point. Oh my goodness. Oh my goodness. Can the critical pressure be equal to pressure at the critical pressure or triple point pressure same है? नहीं. This is triple point which is very much low. Critical is very high. So ये गलत statement है सर. This is a wrong statement. So this statement is wrong. It is MSQ sir. देखो क्यों MSQ आपको कैसे पता? Is R बोला है. Okay, fine. अच्छा क्वेश्चन है. The highest pressure at which vapor can exist is the pressure at the triple point. ध्यान से सुनो. The highest pressure at which vapor can exist. Highest pressure at which vapor can exist is the pressure at the triple point. एक बार देखो, is the pressure at the triple point. देखो एक बार. The highest pressure at which vapor occurs is the pressure at triple point. This is the triple point pressure. वेपर क्या है सर? वेपर इससे ज्यादा है, वेपर इससे ज्यादा है, किससे ज्यादा है? क्या वेपर का प्रेशर हाईएस्ट प्रेशर क्या ट्रिपल पॉइंट के बराबर है? नो, इससे भी ज्यादा है सर, इससे भी. ट्रिपल पॉइंट से भी वेपर का प्रेशर ज्यादा है. सो गलत है सर. सो हाईएस्ट प्रेशर ऑफ द वेपर इज इक्वल टू ट्रिपल पॉइंट बोला, गलत है सर. इट्स नॉट द हाईएस्ट प्रेशर, इट्स वेपर. ट्रिपल पॉइंट से भी वेपर का प्रेशर बहुत ही ज्यादा है. यस, इट्स मोर. सो दिस स्टेटमेंट इज रॉन्ग. दिस स्टेटमेंट इज रॉन्ग. नेक्स्ट. और the highest कहां गए रे वो? The highest temperature at which solid liquid phase can change. The highest temperature at which solid liquid phase can change can happen is the temperature at triple point. क्या बोला है? सॉलिड लिक्विड. देखो देखो एक सेकेंड दोस्तों इधर देखो देखो. This is the triple point temperature. What he is talking about temperature. So horizontal axis पे जाना. He is talking about the temperature. अब बोलो. The highest temperature at which solid liquid phase can change. देखो ये solid liquid. This is phase change. Yes, it lower than triple point. This is phase change solid liquid. This is lower than triple point. This is phase change solid liquid. ये solid liquid है. All these are lower than. But what is the highest temperature at which the change can take place? Triple point. उसके बाहर आपको कोई solid liquid का फेस ही नहीं. So the highest temperature at which solid liquid change is triple point. All others are lower than triple point. बोलो सर, is it clear? So देखो एक बार. The highest temperature at which solid liquid phase can change place. Change can take place. This is the solid liquid. So ये कौन सा टेम्परेचर है सर? It is lower than triple point. ये कौन सा? मैक्सिमम इज ट्रिपल पॉइंट. उससे बाहर सॉलिड लिक्विड नहीं मिलेगा. So the highest temperature at which solid liquid phase change can take place is triple point. So this is also correct. The highest temperature at which solid liquid phase change can take place is the triple point. This is also correct. This is also correct. So कहां गया पेन है? हाँ आया. Yes. So therefore it is D. तो ऑप्शन इज, क्वेश्चन नंबर क्या है सर मित्रों? क्वेश्चन नंबर क्या है? दिस इज 11th. सो 11th A and D मस्त क्वेश्चन है सर. 11th A and D आर करेक्ट. बहुत अच्छा सवाल है सर, बहुत अच्छा लगा मुझे ये क्वेश्चन. इट्स अ वेरी गुड क्वेश्चन. ओके चलो, इन 1 hour वी हैव कवर्ड 11 क्वेश्चंस. मतलब पेस इज वेरी गुड. कर देंगे सर फटाफट. वाह. नेक्स्ट. ये भी अच्छा क्वेश्चन है सर. लेट्स सी दिस क्वेश्चन. हाँ, please read the question. Consider a gas obeying the relationship P into V minus V is equal to RT, where B and R are constant. Which of the following is R? Oh. हाँ. Which of the following is R? Again, it is MSQ. कैसे करेंगे सर? देखो एक बार. What is the equation of the gas? वो बोल रहा है P into V minus V. This is the equation of the gas. P into V minus B is equal to RT. We'll do it, don't worry. ऑप्शन एक बार देख लीजिए। दिस स्पेसिफिक हीट कैपेसिटी एट कांस्टेंट प्रेशर, मतलब ही इज टॉकिंग अबाउट सीपी। CP is independent of temperature, is a function of pressure, is a function of temperature, is independent of both specific volume and temperature. एक सेकंड सुनो मेरे प्यारे दोस्तों, I think you know the I have derived in class the internal energy change energy equation CV dt plus T into dou P by dou TV minus P into dV. दिस इक्वेशन आई थिंक आई हैव गिवन, ये मैं आपको दिया शायद, du इज इक्वल टू सीवी dt प्लस टी इंटू डो पी बाई डो टीवी माइनस पी इंटू डीवी। आई थिंक आई हैव गिवन दिस इक्वेशन, यस आई हैव डिराइव्ड। तो ये लेके क्या करेंगे सर, एक सेकंड, लेट अस कैलकुलेट, ध्यान से सुनो। du इज इक्वल टू सीवी dt किसके लिए लिखेंगे, आइडियल गैस। फॉर आइडियल गैस इंटरनल एनर्जी इज अ फंक्शन ऑफ टेम्परेचर ओनली। अब देखो, बट फॉर अदर गैसेस du इज सीवी dt प्लस समथिंग। आइडियल गैस के लिए ये टर्म जीरो होता है, एंड आइडियल गैस के लिए इंटरनल एनर्जी सिर्फ टेम्परेचर पे डिपेंड होता है। चलो एक सेकंड सुनो, लेट अस कैलकुलेट डो पी बाई डो टी। एक बार देखो, P इज इक्वल टू आर टी बाई वी माइनस बी। ओके फाइन, डो पी बाई डो टी एक बार कैलकुलेट करने की कोशिश करना। डो पी बाई डो टी एट कॉन्स्टेंट वॉल्यूम, dou p differentiate p with respect to t by keeping volume constant. Already b is constant, ये पूरा constant है, r is constant है. You are differentiating this with respect to time, I'm sorry, temperature by keeping volume constant. तो dou p by dou t. सर आपको तो cp पूछा, आप cv क्यों कर रहे हैं? अच्छा सवाल है सर, अप्रोच बताता हूं। h is equal to u plus pv. Correct or not? h is u plus pv. So that's why I'm focusing on U. पहले I'll focus on U, then I'll focus on PV. H is enthalpy. सर आप enthalpy पे क्यों फोकस करें? ये भी अच्छा सवाल पूछा सर आपको। He is asking CP. Don't you know that CP is, देखो CP is equal to dou H by dou T at constant pressure. फर्स्ट आई कैलकुलेट एंथैल्पी, एक बार एंथैल्पी आएगा उसको मैं टेंपरेचर के साथ डिफरेंशिएट करूंगा एट कांस्टेंट प्रेशर, देन यू विल गेट द वैल्यू ऑफ सीपी। दैट इज द इंटेंशन ऑफ फाइंडिंग। देखो मैं कैसे अटैक करके आ रहा हूं, सीपी चाहिए, सीपी इज इक्वल टू डो एच बाई डो टी एट कांस्टेंट प्रेशर। हाँ मतलब एंथैल्पी चाहिए, एंथैल्पी के लिए इंटरनल एनर्जी चाहिए। ऑलरेडी पीवी तो अवेलेबल है, इस गैस के लिए पीवी अवेलेबल है, तो इसलिए मैं इंटरनल एनर्जी कैलकुलेट कर रहा हूं। दैट इज द लॉजिक और सीक्वेंस कनेक्टिंग पॉइंट्स। ओके नाउ व्हाट इज डो पी बाई डो टी? dou p by dou t, you differentiate p with respect to t, dou p by dou t, dou p by dou t किसके साथ, वॉल्यूम कांस्टेंट। तो वॉल्यूम कांस्टेंट देखो, यू आर डिफरेंशिएटिंग बाय कीपिंग वॉल्यूम कांस्टेंट, वॉल्यूम कांस्टेंट b इज ऑलरेडी कांस्टेंट, दिस कांस्टेंट r इज कांस्टेंट, सो dou p by dou t इज r by v minus b। तो क्या होगा इधर देखो, t into dou p by dou t v is r by v minus b माइनस पी। ये टर्म देख रहा हूं सर, आई एम लुकिंग एट दिस टर्म, ये वाला टर्म ले रहा हूं सर, ये वाला टर्म ले रहा हूं, बहुत बढ़िया। टी इंटू व्हाट इज डो पी बाई डो टी, आर इंटू वी माइनस बी। ओके अब देखो, ऑलरेडी यू नो मेरे प्यारे दोस्तों, आर बाई वी माइनस बी, व्हाट इज आर बाई वी माइनस बी? यहां से आर बाई वी माइनस बी इज इक्वल टू पी बाई टी। तो यहां पे p बाई टी पुट करना, दिस विल बी t इंटू p बाई टी पुट करना माइनस p, तो p माइनस p जीरो, तो ये टर्म जीरो हो गया सर, दिस टर्म इज जीरो, मतलब du इज इक्वल टू cv dt। क्या मतलब होगा सर, इंटरनल एनर्जी इज अ फंक्शन ऑफ टेम्परेचर ओनली। तो यहां से आई कैन, सो du इज इक्वल टू cv dt, ये आई हैव थॉट फॉर ऑल अदर गैसेस du इज cv dt, मतलब वो वॉल्यूम पे डिपेंड हो ही नहीं रहा है, ऑटोमेटिकली इस गैस के लिए ये टर्म जीरो हो रहा है, तो इट इज नॉट डिपेंडिंग ऑन वॉल्यूम। समझ में आ रहा है सर? So therefore, now the internal energy of this gas is a function of temperature. ये तो कंफर्म हो गया, internal energy is a function of temperature. But आप पूछेंगे सर internal energy function of temperature is known, but I want enthalpy. एक सेकंड, is U plus PV. मुझे इसका कोई प्रॉब्लम नहीं, इट्स अ फंक्शन ऑफ टेम्परेचर, मुझे ये वाला चाहिए सर। वेरी गुड। अब देखो, लेट्स टेक दिस टर्म, आई वांट CP. व्हाट इज CP? dou H by CP dou T at constant pressure. तो इसको डिफरेंशिएट करना, तो H को डिफरेंशिएट करेंगे विद रिस्पेक्ट टू टेम्परेचर, तो दिस आल्सो शुड बी डिफरेंशिएटेड विद रिस्पेक्ट टू टेम्परेचर, लेकिन एट कांस्टेंट प्रेशर। तो क्या होगा सर, इसका डिफरेंशिएशन क्या होगा? ये तो ऑलरेडी आ गया सर, दिस ऑलरेडी गया, तो पीवी को, दिस इज ऑलरेडी अ फंक्शन ऑफ टेम्परेचर। अब ये देखेंगे किस पे डिपेंड होता है, पी पे या वी पे, जो भी है विल चेक। सो डो एच बाई डो सीपी चाहिए मुझे, अगर सीपी चाहिए डो एच बाई डो टी, इसको एच को टेम्परेचर के साथ डिफरेंशिएट करना, कीपिंग प्रेशर कांस्टेंट। क्या होगा सर, कीपिंग प्रेशर कांस्टेंट, कीपिंग प्रेशर कांस्टेंट, यू आर डिफरेंशिएटिंग एंथैल्पी, तो ये क्या होगा सर? अरे यार समझ में नहीं आ रहा, dou H by dou T is equal to dou U by dou T at constant pressure. So okay, plus ये क्या होगा, dou by dou T of PV at constant pressure. तो प्रेशर कांस्टेंट है तो प्रेशर को बाहर ले लो, इट विल बी dou V by dou T at constant pressure. Already you know P into V minus B is equal to RT. Very good sir. तो मुझे क्या चाहिए P, तो RT by P is equal to V minus B और V is equal to B plus, correct ना? V is equal to RT by P plus B, correct? RT by P plus B. Okay. So what is dou V by dou T at constant pressure? So B is constant, तो differentiation of constant is 0. यहाँ पे क्या constant है? Temperature. Sorry. What is constant? Pressure. तो R is constant, pressure is constant. Now you are differentiating with respect to T. T के साथ differentiate करना, तो T का differentiation क्या होगा? 1 होगा. So this is R by P. This is R by P. Dou V by dou T P is R by P. तो ये आ गया, ये ध्यान से सुनो. तो dou V by dou T P is R by P. लेकिन ये मुझे चाहिए P into, अरे यार, when you are differentiating this, P into dou V by dou T P. What is dou V by dou T P? Dou V by dou T P is R by P. तो ये टर्म सिर्फ R निकल के आ रहा है सर. दिस टर्म व्हेन यू आर डिफरेंशिएटिंग ये सिर्फ R आ रहा है, मतलब कांस्टेंट, बट ऑलरेडी U इज डिपेंडेंट ऑन टेम्परेचर. तो एंथैल्पी इज डिपेंडेंट ऑन टेम्परेचर. सो व्हेन एंथैल्पी इज डिपेंडेंट ऑन टेम्परेचर, माय Cp डिपेंड्स ओनली ऑन टेम्परेचर. इट इज नॉट डिपेंडेंट ऑन प्रेशर एंड वॉल्यूम. नहीं आया सर आपको? लेट मी टेल यू. Already U is a function of temperature, वहां से निकल के आया. So this term when I am differentiating, I am getting a constant आ रहा है सर. इसको अगर dou by dou T P कर रहे हैं तो ये पूरा term constant आ रहा है. Constant which is a function of temperature. So enthalpy is a function of temperature. When enthalpy is a function of temperature, what is Cp? Cp is equal to dou H by dou T at constant dou H by dou T at constant pressure. So therefore when enthalpy is depending on temperature, Cp is depending only on temperature. So in this case it is depending only on temperature. So what is the answer? एक बार देखो. देखो, it is independent of temperature. No, it is dependent on temperature. ये गलत है. It is a function of pressure. No, it is a function of temperature. Yes, it is independent of volume and pressure. Yes, it is not depending on volume and pressure. It is depending only on temperature. So therefore C and D are correct for this question. Similar question I have done in class also. देखो, यहां पे the physical explanation to this can be given like this. देखो यहां पे सिर्फ को वॉल्यूम आ रहा है सर. एक सेकंड बैक ले लेंगे. सो इफ यू सी P plus A by V square into V minus B is equal to RT. तो यहां पे ये रिपल्सिव फोर्स ये नहीं आ रहा है. सिर्फ P into V minus B is equal to RT means it is almost behaving like an ideal gas. That's for ideal gas it's a function of temperature only. तो सिर्फ it is something like this. Axis shift हो रहा है सर. Axis shift हो रहा है. The behavior is not changing. That's it. So therefore, the internal energy is a function of temperature for this gas also, and the Cp is also a function of temperature only. Okay. चलो next. ये अच्छा क्वेश्चन है सर. फटाफट करेंगे सर. Let's not waste time. Read the question. A piston cylinder arrangement means closed system contains an ideal gas mixture of 4 kg hydrogen and 13 kg nitrogen. Oh my god, it is a mixture of gases at 250 Kelvin atmospheric pressure. On heat addition, the mixture expands at a constant, this is the noteworthy point, until the temperature rises to 350. ठीक है sir. What was the initial pressure sir? No, sorry, initial temperature 250 and the final is 350. The isobaric specific heat for hydrogen nitrogen is given. What is the heat added? You know the process is a constant pressure closed system process. For a constant pressure closed system process, the heat transfer is equal to change in enthalpy. For a constant volume closed system process, heat transfer is change in internal energy. But this is a constant pressure process. He is asking heat transfer. So heat transfer is equal to change in enthalpy. And you know, hydrogen is ideal gas and clearly बोला है contains an ideal gas mixture. So it is an ideal gas. So don't worry about that. So as it is an ideal gas, मित्रों, so therefore I can write DH as mCpdt. लेकिन यहाँ पे there is no problem with temperature difference because the final temperature is 350, the initial temperature is 250, temperature difference is known. And mass, what is the total mass? You have 4 kg of hydrogen, 13 kg of nitrogen. So the total mass is 4 plus 13, 17. इसका भी कोई प्रॉब्लम नहीं है सर, सिर्फ प्रॉब्लम सीपी का है, बिकॉज सीपी इज नॉट इंडिविजुअली ऑफ हाइड्रोजन, CP is not individually of nitrogen, it is the CP of the complete mixture. And when I derived, like in class, when I was discussing, I gave one equation. The equivalent specific heat is given by M1 CP1 plus M2 CP2 by M1 plus M2. Already I have derived this. So let us calculate the equivalent specific heat. तो इसको हम ऐसे कर सकते हैं सर? हाँ जी सर. So the equivalent specific heat is given by, what is the mass of, अरे यार फिर नीचे जाना पड़ता है, 4 hydrogen 13 nitrogen, 4 hydrogen 13 nitrogen, 4 hydrogen 4 hydrogen 4 hydrogen. So what is CP of hydrogen? CP of hydrogen 14.239 plus ये भूल गया, देखो कितना था, 4 हाइड्रोजन 13 नाइट्रोजन 13 नाइट्रोजन 13 नाइट्रोजन, इनका है रे 13 नाइट्रोजन 13. What is the specific heat of nitrogen? It is 1.04 1.04. And what is the total mass? M1 plus M2, 4 plus 13. From here you can easily calculate the equivalent specific heat. बोलो कितना आ रहा है सर? मित्रों so 4.14 मैं कैलकुलेट किया सर. Let us not waste. 4.14565, of course kilojule per kg per Kelvin. So now let us calculate the heat transfer. तो ये क्या होगा सर? M is 17 kg. Now the specific heat is equivalent 4.14565 and the difference of temperature is, initially temperature क्या था रे? Initially it was 250, now it is 350. So therefore it is 350 minus 250. So what is the value? Answer check करना. This is kilojoule per kg per Kelvin. Whenever the temperature difference, it is Kelvin or degree Celsius, फर्क नहीं पड़ेगा. Mass in kg. Answer will be in kilojoule. कितना आ रहा है एक बार देखते हैं सर. 100 into 17 into 14.5565. हाँ गलत आ रहा है सर. 100 into 4.14565 into 17. 7047 कुछ आ रहा है सर. Yes, 7047 kilojoule is the right answer. So, but the answer is asked in megajoule. So again you divide with 1000. So you will get megajoule as 7.047 megajoule. So the answer is 7.047 megajoule. That is the right answer. Is it okay? बोलिए मित्रों. Good. Good. We'll move to the next. This is question number. कहाँ गया रे वो? $13. Now we'll move to 14. फटाफट we'll complete it. तो what I am planning is आपको 2026 गेट के लिए कुछ फायदा होने के लिए सॉम थर्मो के आई कंप्लीट, सॉम थर्मो के कुछ प्रीवियस ईयर्स के क्वेश्चंस लेके आई कंप्लीट, मतलब कंप्लीट 25, 24, 23 ऐसा लेके मैं कंप्लीट करूंगा सर. ओके ओके. Diesel, it is a diesel cycle. The air is compressed from 3 liter to 0.3. So volume before compression is 3 liter. Volume after compression is 0.15 liter. Both are in liter. So no need to convert. So what is the compression ratio? Volume before compression to the volume after compression. So it is 3 by 0.15. So from here I can get कितना आ रहा है? I think it is 20 ना? Is it 20? 100. 300 by 15. 20, correct. And देखो, it then expands during constant pressure process heat addition to 0.3 liter. देखो एक second. Let me show you diesel cycle. Isentropic compression, constant pressure heat addition. This is the diesel cycle. This is V1, this is V2, this is V3, and this is V4. ठीक है सर? Correct. देखो, so what is he saying? This volume is given to us as 3 liter. After compression, this volume is given as 0.15 liter. और ये आफ्टर हीट सप्लाई, आफ्टर हीट सप्लाई द वॉल्यूम देखो इट देन एक्सपैंड, देखो एक्सपैंड हो रहा है, वॉल्यूम बढ़ रहा है, वॉल्यूम बढ़ रहा है, वॉल्यूम बढ़ रहा है, वॉल्यूम इट देन एक्सपैंड्स टू V3. व्हाट इज दैट वॉल्यूम? 0.3. ठीक है, ऑल आर इन लीटर. ओके, if the ratio of specific its gamma is 0.4, 1.4, what is the efficiency of the cycle? Wait. In order to calculate the efficiency of a diesel cycle, two parameters are to be found. What are those? One is compression ratio or one is cutoff ratio. What is cutoff ratio? The cutoff ratio is given by volume after heat addition to the volume before heat addition. Heat supply is starting before heat addition, it is V2. After heat addition, it is V3. So V3 by V2. V3 is 0.3 and V2 is 0.15. So what is the value of R, sir? कितना होगा रे? 2. This is cutoff ratio. So you know the compression ratio, you know the cutoff ratio, and gamma value is also known. Let's calculate the efficiency. The efficiency of a diesel cycle is given by 1 minus 1 by R power gamma minus 1. This is the efficiency of Otto cycle. And diesel cycle में ये आएगा sir additionally. This term will come. Okay, so the efficiency is given by 1 minus 1 by the compression ratio is 20, gamma is 1.4 minus 1, and RC cutoff ratio is 2, 1.4 minus 1 by gamma is 1.4, RC is 2 minus 1. तो कितना आ रहा है सर? मुझे पता नहीं है रे बाबा. 2 power 1.4 minus 1 divided by 1.4. 0.646 कुछ आ रहा है सर. Yes. Efficiency is 0.646. If it is asked in percentage, it will be 64.6 percentage. Let me check whether it is percentage or decimal में पूछा. एक बार देखते हैं सर. Percentage में ही पूछा है सर. Yes, it's asked in percentage, so it will be 64.6 is the correct answer. Absolutely fine. ठीक चल रहा है सर. मित्रों ठीक चल रहा है रे? हाँ जी सर जी. ठीक है, no problem at all. Okay, fine. So how many questions did we complete? 14. Let's go to the 15th. Read this question. हो गया सर. 15th. Air at 101 kilopascal, that is the total pressure, 15 degrees centigrade. Okay, this is the dry bulb temperature. If nothing is mentioned, it is the dry bulb temperature. And 50% relative humidity is first heated to 20 degrees centigrade in a heating coil and then humidified by spraying water on it. अच्छा, it is heated from 15 to 20, मतलब sensible heating है. Okay, and then humidified by spraying water. And the final state is 25 degree. The relative humidity is 85%. The amount of water sprayed is. अच्छा, okay. फिर ये वाला लेना पड़ेगा सर. ये डेटा तो चाहिए मुझे. हाँ देखो, लेट मी शो ऑन साइक्रोमेट्रिक चार्ट. इनिशियल टेम्परेचर ऑफ एयर दिया है सर. व्हाट इज द इनिशियल टेम्परेचर ऑफ एयर? 15 डिग्री सेंटीग्रेड. 15 डिग्री सेंटीग्रेड. Okay, it is heated to 20 degrees centigrade. Okay, on this axis we have dry bulb temperature. On this axis you have specific humidity. Now what he is doing is, like after heating, he is spraying water and finally the temperature is also given. एक बार देख लेना sir. So the final temperature is 25 degrees centigrade, but the humidity is increasing from 50 to 85%. The initial humidity is 50%. Okay, to 85%. देखो एक बार. Here the relative humidity. देखो एक सेकंड, मैं कलर चेंज करता हूं सर. I think I like this color. चलो कोई नहीं. ये relative humidity हो गया यहां का 0.1 का. This is given as 50%, I think. 5. So then, देखता हूं सर एक बार. Heat is humidified. Humidified का मतलब क्या है? Omega is increasing. So therefore, this is omega 3. And the final temperature is 25 degree centigrade. This is the temperature. ये दे रखा है. एक बार मैं क्वेश्चन की तरफ जा रहा हूं सर. And the relative humidity here is 85%. Initially, it is 15 degree, 50% RH, and 85% is the relative humidity here. यहाँ पे it is 85%, sir. This relative humidity is 85%. Now, let's do this question. अब देखते हैं सर क्या पूछा है. I don't know what is asked. एक बार देखते हैं. Amount of water sprayed in gram per, okay, in gram per kg dryer. Amount of like water added. Okay, amount of water sprayed. देखो, what is omega at this point and at this point? It is a sensible heating. तो यहाँ पे it is a horizontal line. So therefore, from 1 to 2, the omega is remaining constant. So here the moisture is added, therefore the value of omega is increasing from omega 2 or omega 1 to omega 3. So what I do is, I will calculate the specific humidity at 1, then I will calculate the specific humidity at 3, because specific humidity at 1 and 2 are same, because it is a sensible heating. तो यहाँ का omega calculate करूंगा, यहाँ का calculate करूंगा, the difference will be equal to amount of water vapor added. Very good. So how do I calculate omega 1? देखो एक बार, omega 1 is equal to 0.622 PV by P total minus PV. So I do not know the partial pressure of vapor at point 1, but I know relative humidity. So phi is equal to PV by PVS. You know this. अगर phi 1 चाहिए तो ये होगा सर PVS. So 1 is at what temperature? It is at 15 degrees centigrade. 1. And phi 1 is already known to me. Phi 1 is 0.5. That is equal to PV1 by PVS1. What is PVS1? It is the saturated pressure of vapor at 1. 1 means 15 degrees centigrade. The saturated pressure of vapor at 15 degrees is 1.7057. From here, I'll calculate PV1. Batao sir, what is PV1? Correct. 0.85285. Of course, kilopascal. ठीक है sir. Now, once PV1 is known, तो यहां पुट करना. तो omega 1 is equal to 0.622. PV1 is 0.85285, and the total pressure is given. What is the total pressure, sir? Atmospheric pressure 101 kilopascal. 101 kilopascal. 101 kilopascal minus 0.85285. देखो एक बार, PV1, P total minus PV. तो from here I will calculate omega 1. So अगर हम calculate करेंगे तो ये आ रहा है 5.297 into 10 raised to minus 3. What will be the unit of omega? kg vapor per kg dry air. ये होगा सर. Now let's calculate omega 2. No need to calculate omega 2 because omega 1, omega 2 तो same ही है because it is sensibility. Omega 3. How to calculate omega 3? Same procedure because phi is given. तो यहाँ phi से phi 3 is, देखो phi 3, एक सेकंड, phi 3 is PV3 by PVS3. Phi 3 is 0.85, that is equal to PV3 by PVS3. So what is the saturated pressure? देखो 3 is at what temperature मित्रों? 3 is at 25. तो at 25 the saturated pressure is 3.1698. तो यहाँ पे 3.1698. So यहाँ से I'll calculate the value of PV3. What's the value of PV3? PV3 will be equal to 2.694. Once PV3 is known, no one can stop you in calculating the value of what? Omega 3. So omega 3 will be equal to 0.622 PV3 2.69433, and the total pressure is 101 minus PV3 2.69433. So यहाँ से I'll get the value of omega 3. What's the value of omega 3? It is 0.01705. 0.01705. Once this is known, the moisture added will be equal to omega 3 minus omega 1. So omega 3 is 0.017. This is 1705 minus 5.297 into 10 power minus 3. So from here, moisture added will be so many kg of vapor per kg dry air. तो कितना आ रहा है सर? 0.0. It is 0.01175. 0.01175 kg vapor per kg of dry air. But एक बार unit check करना सर. In which unit is he asking? We got 0.01175. He is asking in gram per kg per dry air. तो क्या करेंगे सर हम? What to do? क्या करेंगे सर? So इसलिए 0.01175 into 1000 because this is so many kg vapor per kg dry air. तो kg dry air वैसे ही रखो, kg वेपर को 1000 से मल्टीप्लाई करेंगे तो ग्राम ऑफ वेपर आएगा सर. सो देयरफॉर इट विल बी 11.75 ग्राम ऑफ वेपर पर किलोग्राम ऑफ ड्राई एयर. 11.75 कहां है? ये सही है गलत है? यस, 11.75 इज द करेक्ट आंसर. ओके, चलिए. वंडरफुल सर, वंडरफुल. लेट्स नॉट वेस्ट टाइम. हाउ मेनी क्वेश्चंस डिड वी सॉल्व? 15. Another 7 questions are left. Take this question. A stream of superheated steam mixes with another stream of superheated steam through a steady state adiabatic process. Okay. The flow rates of the streams are 3 and 2 respectively. Okay. The mixture then expands in an adiabatic nozzle acha, to a saturated mixture with the quality dryness fraction. Okay, given. Neglect the velocity at the inlet to the entrance of the nozzle and changes in potential energies are neglected. The velocity at the nozzle exit is. Must question hai sir. This question is very good question. एक बार मैं कर देता हूं sir. Actually, what is he talking about? ये प्लेस चलो. There is one stream of steam, superheated steam. There is another stream of superheated steam. They are mixing and the resultant is 3. और ये क्या हो रहा है? It is then entering the nozzle and finally it is coming out at 0.4. He is asking the velocity of the steam which is exiting from the nozzle. जो nozzle से बाहर आ रहा है, fluid, steam जो भी आ रहा है, उसका velocity पूछा है सब. And he also said that the velocity at the inlet to the nozzle is, in का मतलब nozzle, negligible. I think, एक बार देखो सर, 2 megapascal 300, ये वाला है 2 megapascal, this is 2 megapascal 300 degree centigrade. ये वाला क्या है सर? The second one is 2 megapascal 400. 2 megapascal 400. 2 megapascal 400. ठीक है सर, no problem. And the dryness fraction here is given. मतलब exit पे दिया है ना? 0.77 कुछ दिया है. हाँ ना. The mixture is then expands in nozzle to a saturated mixture. अच्छा. So मिक्सचर एक्सपेंड होने के बाद ये ड्राइनेस फ्रैक्शन है सर. हाउ टू प्रोसीड? कुछ नहीं है सर, बहुत सिंपल है. और एक बात, कुछ डेटा दिया है सर? विदाउट डेटा वी कैन नॉट डू. एक सेकंड देखता हूं. हाँ, डेटा दिया ना रे, डेटा इज गिवन. अच्छा, यहीं पे करेंगे तो ठीक रहेगा सर. तो एक सेकंड, इसका मास कितना? यहीं पे करेंगे तो ठीक रहेगा. मास दिया है सर. पहले वाले का मास है 3, फर्स्ट 300 डिग्रीज का 3 है और 400 का 2 है सर. ओके, मैं कर देता हूं सर. देखो, आई डू इट सर, आई डू इट, डोंट वरी. मस्त क्वेश्चन है सर. देखो, एंड डेफिनेटली दीज क्वेश्चंस विल बी यूजफुल टू यू इन, क्या बोलते हैं, गेट प्रिपरेशन में. this is 1, this is 2, this is 3, and there is a nozzle, and this is 4. Here the dryness fraction is given as, yes, and he also gave the pressure. यहाँ का pressure भी दे रखा है सर, 1 kilopascal. Yes. So enthalpy of saturated vapor, the enthalpy of saturated water. तो यहाँ का at 1 enthalpy of saturated water का मतलब saturated liquid, it is 29.3, and the enthalpy of saturated liquid at 1 kilopascal. Because आपको कैसे पता यहाँ पे, he clearly said it is exiting the nozzle at 1 kilopascal. Okay, so it is 2513.7. 2513.7. ठीक है सर. Now देखो, here the mass is given as 3, and here the mass is given as 2. What will be the mass at 3? Because 3 is entering, 2 is entering, दोनों mix होने के बाद resultant mass at 3 will be 5 kg. Very simple sir. I'll calculate the enthalpy here, but यहाँ के enthalpies पता है सर, एक बहुत simple है सर. Here the temperature is given as 300 degrees centigrade, and here the temperature is given as 400 degrees centigrade. तो enthalpies तो दे रखा है सर. It is given, देखो एक बार. At 200, 300, the enthalpy of superheated is 3024.2. So here the enthalpy is 3024.2, and this enthalpy is also given at 400 degrees centigrade. 3024.2, 400 degrees centigrade पे 3248.4, 3248.4, 3248.4. Okay, now can I calculate the enthalpy at this? Very simple sir, from the conservation of energy, and moreover mixing में you don't get any work, or not you give any work, and it is adiabatic mixing, simply enthalpies, and mixing में like kinetic potential energies तो negligible रहेंगे. तो यहाँ पे m1h1 plus m2h3 is equal to m3h3. अप्लाई करो conservation of energy. m1h1 plus m2h2 is equal to m3h3. How did you get m3? This plus this. So m1 is 3 kg, h1 is 3024.2, plus m2 is 2, and h2 is 3248.4, and m3 is 5 into h3. From here you can easily calculate the value of h3. कितना हो रहा है सर? 3024.3 into 3, 2 into 3 to 4. So h3 will be equal to, this is 5h3. So h3 is 3113.8. 0.8. Yes. क्या पूछा है सर? Now, my dear students, let me apply the steady flow energy equation for the nozzle. What will be that? H3, inlet is 3, exit. H3 plus P3 square by 2. He said neglect potential J. Z3 हो नहीं रहेगा. And पूरा equation लिखेंगे. Z3Z plus Q is equal to H4 plus C4 square by 2 plus Z4G plus W. So it is adiabatic nozzle बोला है 0. Nozzle में there is no work transfer. So kinetic potential and potential energies are neglected. How can kinetic be neglected in nozzle? People will beat us on roads. So inlet velocity is negligible बोला. So H3 is equal to H4 plus C4 square by 2. लेकिन यहाँ पे you may be committing a mistake. As these are in kilojoule per kg, this should also be in kilojoule per kg. So it should be 2000, which I explained everything clearly in class. Unfortunately, H4 is not known, but all the data is given. Can I calculate the enthalpy at 0.4? Yes, why not? Of course we can calculate. एक बार calculate करने की कोशिश करेंगे सर. H4, the enthalpy at the nozzle exit H4. It is in the wet region. So H4 is equal to HF plus X into HG minus HF. So therefore H4 कितना आ रहा है सर? कहाँ पे? I don't know. What is HF? HF is equal to 29.3, and the dryness fraction is 0.77 into Hg is 2513.7 minus HF is, what is HF? 29.3. So यहाँ से everything is known. I can easily calculate H4. If I calculate H4, यहाँ पे तो calculate भी नहीं किया सर. 1942.3. 1942.3. Put करो यार. H3. What is H3? 3113.8 is equal to H4. अभी तो calculate किए. 1942.3 plus C4 square. I do not know by 2000. एक बार check करेंगे sir. What is the velocity at the exit of the nozzle? nozzle is used for increasing the kinetic energy. 1530 कुछ आ रहा है सर, बिल्कुल सही है सर. C4 is 1530, huge velocity. So the answer is 1530. अच्छा क्वेश्चन है सर. So the answer is 1530. एक बार आप क्रॉस चेक कर लेना सर विथ गेट की. You just check with gate key. Okay, chalo. Next is question number. We are nearing, sir. 17. ये करो. 17. A piston cylinder assembly. Again, it is a closed system having 250 mm diameter. Contains 0.01 kg of water vapor at 1 megapascal and 200 degrees centigrade. The specific volume of the vapor is 0.20. The system expands as per the relation P per N, where P is the pressure, V is the volume. The expansion of the water vapor displaces the piston by 50 mm. If the final pressure is 0.35, the value of the polytropic index or the value of the exponent N is, ठीक है सर. एक बार क्वेश्चन देखो सर. It is a piston cylinder assembly. What is the mass? What is the diameter of this, sir? 0.25 meter. 250 mm is 0.25 meter. And the mass is given as 0.01 kg. ठीक है सर. Water vapor at 1 megapascal 200. The specific volume is also given. How much is this? 0.20602. मेरे प्यारे दोस्तों. And what is the pressure given, sir? Initial pressure. The initial pressure is 1 megapascal. Observe carefully. The initial pressure is 1 megapascal. The specific volume is given and the mass is given. When the specific volume, but याद रखना, ये PV power N is equal to constant. V is the volume. It's not a specific volume. Okay. Where V is the volume, clearly बोला है sir. V is the volume बोला है. How to calculate volume? Specific volume is volume by mass. If you want volume, it will be mass into specific volume. So what is the mass? 0.01 and the specific volume is 0.20602. तो यहां से वॉल्यूम आ जाएगा सर. It will be 2.0602 into 10 power minus 3. This is the volume. ठीक है सर. And what is the final pressure? 0.35. ठीक है सर. But यहाँ पे क्या है ना, the volume is increasing, the system is expanding. So therefore क्या करे सर? अब देखो एक सेकंड. It is this piston displaces by 50 mm. Let's see the final position. एक बार final position देखना. Initially ऐसा था and initial volume is known. Now finally एक बार देखो, ये वॉल्यूम है सर. तो अगर आप देखेंगे, दिस इज द डिस्प्लेसमेंट. व्हाट इज द डिस्प्लेसमेंट? कितना डिस्प्लेस हुआ? 50 mm. तो कैन आई कैलकुलेट माय डियर स्टूडेंट्स दिस वॉल्यूम? यस. द डायमीटर इज गिवन, pi by 4 d square is the area into this displaced length. So this volume will be obtained. If I want the final volume, it will be the initial volume plus this displaced volume. I repeat sir, initially कुछ volume था, yes, initially कुछ volume था, हीट किए तो या फिर जो भी प्रोसेस किए तो एक्सपैंड हो रहा है. सो फाइनल, दिस इज द फाइनल वॉल्यूम. ये पूरा फाइनल वॉल्यूम है सर. तो फाइनल वॉल्यूम इज इक्वल टू इनिशियल वॉल्यूम प्लस ये वाला वॉल्यूम. व्हाट इज दिस वॉल्यूम? pi by 4 d square into this displaced length 50 mm. तो यहां से I can easily calculate the final volume. ये तो इनिशियल वॉल्यूम आ गया. The final volume is, the initial volume is 2.0602 into 10 power minus 3 plus pi by 4 and the diameter is, what is the diameter sir? 0.25 to whole square and the length is 0.05 mm. 0.05 कितना आ रहा है सर? Is this correct? 50 mm is 0.5. Correct. So you will get the final volume as 4.51457. 4.51457 into 10 power minus 3. और क्या है सर? Where is the problem? Initial pressure P1 is 1 megapascal Initial volume is known. Final pressure P2 is 0.35. The final pressure P2 is 0.35. Arey yaar. And the final volume is this much. So can I calculate adiabatic, the index n? देखते हैं sir. एक second. So P1 V1 raised to n is equal to P2 V2 raised to n. ठीक है. So can I write this as P1 by P2 is equal to P1 by P2 is V2 by V1 power n, 100% sir. So take logarithm. Log of P1 by P2 is equal to log of V2 by V1 whole power n, that n will come here. तो अगर आपको index n चाहिए, if you want index n, it will be ln P1 by P2 by ln V2 by V1. Absolutely fine. So this will be ln. Initial pressure is given as कितना दिया था sir? Initial pressure 1. Both are in megapascal, no need to convert. And the final pressure is 0.35. And the initial volume is known, final volume is 4.5145 into 10 power minus 3. And the initial volume is 2.0602. 2.0602 into 10 power minus 3. तो यहां से you will get the value of n. तो n का वैल्यू आएगा सर. If you are, एक बार चेक करता हूं सर, 4 point, yes. Correct. So if you are calculating, you are getting the value of n as 1.338. Yes, 1.338. Correct. So this completes our 17 questions. Last 5 questions are left. Let's complete. ये करो. Good question. First you read the question. एक बार रीड करो, थोड़ा ब्रेक ले लो, 1 मिनट का ब्रेक ले लो. Air enters a hair dryer at 22 degrees centigrade and 100 kilopascal with a velocity of 3.7 and leaves the dryer at 83 degrees centigrade and 100 kilopascal. अच्छा, pressure is not changing, constant pressure. Okay. Velocity, kinetic energy is also changing, मतलब enthalpy change हो रहा है. The exit area of the dryer is given and the ambient temperature is also given. The air is an ideal gas with the gas constant so and so. If the changes in kinetic energies are potential energy is neglected, what is the second law efficiency? Again, you read the question, sir. Again, पढ़ो एक बार. Yes, I'll get back. ठीक है, चलिए. मस्त क्वेश्चन है सर. क्या करेंगे सर? एयर इज एंटरिंग अ हेयर ड्रायर एट 22 डिग्री सेंटीग्रेड. तो मुझे ना, मैं एक काम करता हूं सर, आई विल टेक द क्वेश्चन. एक बार पढ़ो आप. इट इज एंटरिंग द ड्रायर एट 22 डिग्री सेंटीग्रेड एंड 100 किलो पास्कल विथ द वेलोसिटी ऑफ दिस. चलो कोई बात नहीं, इधर से ही कर लेंगे सर. लेट अस अज्यूम दैट हेयर ड्रायर में क्या होता है, अरे हीट करते हैं. चलो ये मान लो हेयर ड्रायर. दिस इज द इनलेट एंड दिस इज द एग्जिट. ठीक है सर जी. मित्रों, एयर एंटर्स द हेयर ड्रायर एट 22 डिग्री सेंटीग्रेड 100 किलो पास्कल. इज इट 100 किलो पास्कल? एक बार देखते हैं सर. with a velocity of 3.7. with a velocity of 3.7. अच्छा क्वेश्चन है सर, आई डू इट. एंड और क्या दिया है? velocity of 2200 kilopascal. Okay. And leaves at 83 degrees centigrade, 83 100 kilopascal 9.1, 83 100 kilopascal 9.1, 83. The temperature is 83 degrees centigrade, 100 kilopascal, and velocity is 9.1 meter per second. These are the conditions given, sir. एक second. The area is also given. Dryer का area, exit area of the dryer given है. ओके अच्छा, तो ऐसा कर सकते चलो कोई बात नहीं। ये गलत है सर, मैं बताता हूँ एक्चुअली। ओके, ही इज आस्किंग द सेकंड लॉ एफिशिएंसी। मैं फिगर चेंज करता हूँ सर, आई विल चेंज द फिगर बिकॉज द एग्जिट एरिया इज आल्सो गिवन ना। मैं बताता हूँ सर हाउ टू डू इट, डोंट वरी। जो भी है, दिस इज ड्रायर, दिस इज सेक्शन 1 एंड दिस इज सेक्शन 2। ठीक है सर। He is asking second law efficiency. Sir. Second law efficiency we have discussed for a refrigerator, we have discussed for an engine, but for a dryer? Yes sir. Heating elements, cooling elements, उसका भी second law efficiency होता है। Physical meaning बताता हूं सर। हम इसको कुछ एनर्जी इनपुट दिए सर, ध्यान से सुनिएगा। I have given second law efficiency is always talking about the quality of energy। ठीक है सर जी, ये T1 है, ये T2 है, ठीक है, कोई दिक्कत नहीं सर। Observe here. We have supplied energy, तो उसका एनर्जी बढ़ गया। यहां से कितना एनर्जी सप्लाई की पता चलेगा, लेकिन डू यू थिंक ऑल द एनर्जी कैन बी यूटिलाइज्ड? नहीं सर। तो व्हाट आई डू इज I will calculate the increase of availability. यहां से यहां तक कितना availability बढ़ गया by energy supplied will be the second law efficiency. Let me repeat, sir. It's a flow process, sir. It's a flow process. Fluid is entering and leaving. Okay, मैं क्या बोल रहा हूं सर आपको? What I do is, एक सेकंड ध्यान से सुनो, कोई टेंशन मत लेना। How much energy we have supplied, यहां से लेकर यहां, we will calculate. उसके बाद में what को हम तो सप्लाई कर रहे हैं, वी आर सप्लाइंग, बट डू यू थिंक ऑल हैज गॉन टू द क्वालिटी ऑफ इंक्रीज ऑफ अवेलेबिलिटी? नो। सो इवन दो आई एम गिविंग, फॉर एग्जांपल आई एम स्टडिंग फॉर 8 hours, that is the complete 8 hours going for the quality of studying? No, maybe 4 hours. So what I do is I will calculate the increase of availability. यहां से यहां तक availability कितना बढ़ गया, that is the actual, by input कितना भी यहां से यहां, I will calculate that energy input. So therefore, the second law efficiency in this case is energy input that you are giving to the increase in availability. ये बहुत इंपॉर्टेंट है सर। दिस टाइम यू कैन एक्सपेक्ट दिस इन मैकेनिकल इंजीनियरिंग। ये तो एक्सी में आया था, चलो कोई बात नहीं, अब करेंगे। व्हाट इज द एनर्जी इनपुट दैट यू आर गिविंग? लेट्स कैलकुलेट फ्रॉम हियर टू हियर। हम कैलकुलेट करेंगे। तो देखो, पोटेंशियल एनर्जी चेंजेस तो नेग्लिजिबल बोला, फिर क्या एनर्जी चेंजेस हुए? यहां का टेम्परेचर बढ़ गया, यहां का टेम्परेचर बढ़ गया, कोई बात नहीं सर। विच फ्लूइड इज फ्लोइंग? एक बार देखो, एक सेकंड, विच फ्लूइड? एक सेकंड, एयर, कोई बात नहीं सर। हाँ, व्हाट इज द एनर्जी चेंज दैट इज हैपनिंग? यहां का टेम्परेचर बढ़ गया, यहां का मतलब एंथैल्पी डिफरेंस और काइनेटिक एनर्जी डिफरेंस। पोटेंशियल तो नहीं है, सो देयरफॉर नाउ आई विल राइट द एनर्जी इनपुट दैट यू आर गिविंग इज H2 minus H1 plus C2 square minus C1 square by 2000 किलोजूल पर केजी। सो देखो, द फाइनल एनर्जी इज H2। देखो, आपको समझ में नहीं आया, आई विल एक्सप्लेन अगेन, डोंट वरी, आई विल एक्सप्लेन अगेन। फाइनली क्या क्या एनर्जी फॉर्म्स है एक बार देखना। व्हाट आर द फॉर्म्स ऑफ एनर्जी दैट यू हैव? अब देखो, यहां पे तो टेम्परेचर मतलब एंथैल्पी फॉर्म, और क्या है? काइनेटिक एनर्जी। तो व्हाट इज द फाइनल एनर्जी? पोटेंशियल एनर्जी में कोई बदलाव ही नहीं है, वो बोला है। तो H2 plus C2 square, of course 2000. What is the initial energy? Initially it is H1 plus C1 square. So this difference will give me the energy supplied. So what is the energy supplied? The energy supplied will be equal to H2 minus H1 means Cp into T2 minus T1 plus C2 square minus C1 square by 2000. Absolutely fine. So the energy supplied will be equal to Cp is 1.005. Whenever it is difference of temperature, it doesn't matter whether it is in Kelvin or degree centigrade. कोई फर्क नहीं पड़ेगा सर. चाहिए तो आप दोनों को केल्विन में कन्वर्ट करके करना, फिर डिफरेंस विल बी सेम. सो T2 is 83 and T1 is 22 plus C2 square is 9.1 square minus C1 square is 3.7 square by 2000. So can you give me? It will be in kilojoule per kg. एक बार देखो कितना आ रहा है सर. 1.005. 9.1 square. So I think you are getting this as 61.34 kilojoule per kg. Absolutely fine. So इससे कोई प्रॉब्लम नहीं होगा. तो there is no need to take the area and calculate the mass flow rate because यहाँ पे mass flow rate, यहाँ पे mass flow rate सेम तो रहेगा तो कैंसिल हो जाएगा. पर kg कैलकुलेट करेंगे तो भी कोई फर्क नहीं पड़ेगा. Now I'll calculate the increase of availability. ध्यान से सुनो. How to calculate the increase of availability? एक बार देखना. You know, my dear students, if you want to calculate the availability of 1, it will be with respect to dead state 0. If you want to calculate the availability of 2, it will be with dead state 0. That is atmospheric. So difference क्या होगा? दोनों में atmospheric common होके निकल जाएगा. So you know, for open system, it is a flowing. It is flowing. For open system, what is the increase in availability or the maximum work? देखो, you know, the change in अरे हो क्या रहा है रे? हाँ, the increase in availability or the change in availability is H2 minus H1 minus T0 into S2 minus S1. लेकिन this is when the kinetic energies are neglected. Plus यहाँ पे kinetic energies है, तो इसीलिए you have to take this. इसलिए, so therefore H2 minus T0 S2 plus C2 square minus this. This is already a similar question I have done in class. This is when you take kinetic energies into consideration. तो फर्क क्या है सर? Already आप ना ये वैल्यू और ये वैल्यू ऑलरेडी आप कैलकुलेट कर चुके हैं सर. वो 60 देखो एक बार H2 minus H1 C2 square minus C1 square ऑलरेडी आप कैलकुलेटेड. सिंपली इस वैल्यू से जो 60 ये वैल्यू कितना आ रहा है सर? दिस एंड दिस पुट टुगेदर वी गॉट 61.34. उसमें से T0 S2 minus S1 करेंगे तो I'll get the increase of availability that you put in numerator and energy supplied 61.34 in the denominator. You will get the answer. लेकिन मुझे entropy change calculate करना है. Already ambient temperature is given. How much is the ambient temperature, sir? What is the ambient temperature? The ambient temperature is somewhere it is given, I think. Yes. देखो, the ambient temperature is 22. It should be in Kelvin. 22. It should be in Kelvin. 22, no problem. So, अब problem क्या है ना? The only problem is to calculate the entropy change. The working fluid is an ideal gas. For ideal gas, एक बार देखो, what is the entropy change? You know, delta S is equal to Cp ln T2 by T1 minus R ln P2 by P1. What is the pressure at 1 and 2? At 1 and 2, the pressure is same. This ratio is 1. Log 1 is 0. ये कट जाएगा. So, entropy change will be equal to Cp ln T2 by T1. Cp is 1.005. into ln and this temperature it's a ratio not a difference of temperature. It should be in Kelvin. T2 को Kelvin में convert करना 273 ऐड करो 6 356 I think 356. एक बार देखो 6 yes divided by T1. What is T1? 273 मतलब 295. एक बार देखता हूं सर. Correct. So this is 0.1889. 1889. ठीक है सर. तो अब यहां लेट्स कैलकुलेट दिस मित्रों. लेट्स कैलकुलेट द इंक्रीज ऑफ अवेलेबिलिटी. सो द इंक्रीज ऑफ अवेलेबिलिटी 61.34 माइनस द एम्बिएंट टेम्परेचर 22 था ना. 22 था. So 22 means 273 plus 22 is 295 and the entropy difference is we got this as 0.1889. तो अगर ये कैलकुलेट कर रहे हैं मित्रों 0.1889 into 295 minus 61.34 ये आ रहा है 5.616. इसका फिजिकल मीनिंग क्या है सर? I am supplying 61.34 units of energy, but the actual increase of the quality of energy is only this much. So what is the second law of efficiency? Actual increase इतना ही हुआ. मैं तो 60 घंटे पढ़ लिया, लेकिन 5 घंटे ही effective होगा. So what is your second law efficiency? 5 by 60. So this is 5.616 by 61.34. So is he asking in percentage, Mitro? Yes, it is asked in percentage. So therefore, you multiply. अरे कहाँ गए रे वो? अरे कहाँ गए रे वो? हाँ, you multiply this with 100. So the value is कितना आ रहा है सर? 9.15. The answer एक बार प्लीज फाइनल गेट की से एक बार आंसर्स चेक कर लेना प्लीज. इट्स अ रिक्वेस्ट ऑल ऑफ यू, एक बार चेक कर लेना रेंज में आ रहा है या नहीं. अगर नहीं आया तो विल डिस्कस अगेन. ये 18th क्वेश्चन होगा, मस्त क्वेश्चन था सर. 9.15 इसका आंसर 9.15. So answer is 9.15. Move to the next. ये करो. ये भी अच्छा क्वेश्चन है सर. हो गया सर. 19. Make it fast, make it fast. Let's not waste time. पढ़ो एक बार. चलो. स्टीम बॉयलर. तो आप बताइए क्या बॉयलर का वॉल्यूम चेंज होगा? ना. सो इट इज अ फिक्स्ड वॉल्यूम, मींस कांस्टेंट वॉल्यूम. कंटेन्स सैचुरेटेड वाटर वेपर मिक्सचर एट 200. मतलब सैचुरेटेड वेपर. अच्छा, इट इज सैचुरेटेड वेपर 200. द टेम्परेचर ऑफ द बॉयलर ड्रॉप्स फ्रॉम 200 to 110 when it is losing heat. Assume all the walls of the boiler are closed. क्या मतलब है सर? ये closed system है, ठीक है. And the energy is lost as the heat to the surrounding. The ratio of mass of liquid to the mass of vapor. Must question है सर, must question है. एक सेकंड, read the question properly again. Actually एक boiler है, उसमें saturated water vapor है सर, मतलब G state पे saturated water vapor at 200. And it starts losing heat and the temperature drops down to 110. And he is asking finally when it loses heat and reaches 110, what is the ratio in the final condition, the ratio of liquid mass to the vapor mass. अच्छा, ये पूछा है सर, ratio of liquid mass to the vapor mass and other conditions are given. चलिए अब करेंगे. इसको ऐसे करेंगे सर. देखो इसमें डेटा कुछ है सर. ओके 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 ओके, ठीक है. देखो, लेट मी डू दिस. दिस टेम्परेचर इज आई थिंक 220 या कुछ दिया, 200 दिया सर. And this is given as some 100. Sorry, 110. Why am I showing like this? Anyone in the class? Okay, ये हम ले लेंगे. पागल है हम. गलत है. ये गलत है सर. No. No, 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 no. I'll remove. Let me take TV. क्या फर्क पड़ता है? Initially saturated vapor था, finally इधर आ गया. So therefore it is a constant volume processor. Why? Boiler में whatever the volume is there, simply वो container में initially पूरा vapor था, it starts losing heat, losing heat, losing. Some liquid is converted into. Originally everything was vapor. Now after losing heat and drops down to 110, it becomes liquid vapor. He is asking the ratio of liquid to vapor in the final condition. कैसे calculate करेंगे? Very simple sir. This volume is equal to this volume. चलो क्या वॉल्यूम है देखो मेरे प्यारे दोस्तों. व्हाट इज द वॉल्यूम इनिशियली 200 पे? इट इज 0.127. तो V1 इज इक्वल टू क्लोज्ड सिस्टम. ध्यान से सुनो, टोटल वॉल्यूम एट 1 इज इक्वल टू टोटल वॉल्यूम एट 2 और the specific volume at 1 is equal to specific volume at 2. Why? Because it is a closed system. तो closed system है तो मास चेंज नहीं होगा। जब वॉल्यूम चेंज नहीं होगा, मास चेंज नहीं होगा, स्पेसिफिक वॉल्यूम इज वॉल्यूम बाय मास, मास इज नॉट चेंजिंग क्लोज सिस्टम, वॉल्यूम इज नॉट चेंजिंग, सो वॉल्यूम बाय मास इज स्पेसिफिक वॉल्यूम। तो क्लोज्ड सिस्टम कांस्टेंट वॉल्यूम प्रोसेस में नॉट ओनली द वॉल्यूम इज कांस्टेंट बट स्पेसिफिक वॉल्यूम विल आल्सो बी कांस्टेंट बिकॉज मास इज नॉट चेंजिंग। ओके, V1 is V2. तो व्हाट इज V1? 200 डिग्री सेंटीग्रेड पे द वॉल्यूम इज 0.127. This is equal to V2. But V2 is in the wet region. So this can be written as Vf plus X into Vg minus Vf. Okay, sir. So 0.127 is equal to Vf. So at this इस वॉल्यूम में, सॉरी, ये 110 पे लिक्विड का 110 पे, व्हाट इज द लिक्विड वॉल्यूम, सैचुरेटेड लिक्विड स्पेसिफिक वॉल्यूम देखो, Vf सैचुरेटेड स्पेसिफिक वॉल्यूम ऑफ द लिक्विड 110 पे 0.001 X into Vg. What is Vg at 110? 1.21 minus Vf is 0.001. So everything is known except X. कितना आ रहा है मित्रों? कितना आ रहा है मित्रों? 0.127, 0.001. मेरे प्यारे दोस्तों, 0.127 minus 0.001. 0.1042. इजी आस्किंग दिस, मेरे हिसाब से ये नहीं पूछा, पूछा क्या है सर, एक बार देखो, द रेशियो ऑफ मास ऑफ लिक्विड टू द मास ऑफ वेपर, लिक्विड टू द मास ऑफ वेपर, x इज इक्वल टू, डिस्ट्रैक्शन इज मास ऑफ वेपर बाय मास ऑफ वेपर प्लस मास ऑफ लिक्विड, दिस इज 0.1042. मुझे क्या चाहिए सर? आई वॉन्ट लिक्विड टू वेपर, मुझे लिक्विड टू वेपर चाहिए, तो उल्टा करो, लिक्विड टू वेपर चाहिए, उल्टा करो, तो क्या होगा? ml प्लस mv बाई mv इज इक्वल टू, उल्टा करो इसको, उल्टा, तो उल्टा कितना होगा सर? 9.59. सो ml बाई mv प्लस mv बाई mv इज 1, 9.59. तो ml बाई mv इज इक्वल टू 8.59. देखो ये उधर जाएगा, 8.59. It is the right answer, sir. 8.59 is the right answer. Last 3 questions. 8.59 is the right answer. This is the final answer. Mass of liquid to mass of vapor. Okay, sir. Okay, sir. Okay, sir. Okay, sir. ये करो, जल्दी जल्दी करो. 2 Carnot engines E1, E2 are operating in the series. The higher temperature is 16 and it develops work W1. Engine E2 receives from the intermediate source at T and does work W2. Rejects heat at 400. So, अच्छा, what is the intermediate temperature? Okay, 1600, 400. ये दिया सब. This temperature is 1600 Kelvin. This temperature is T and this is 400 Kelvin. These are engines in series. पूछा क्या है सर? These engines are coupled in series. कंडीशन क्या दी एक बार देखो सर. द कंडीशन इज गिवन एज बोथ इंजिन्स हैव सेम एफिशिएंसी, सेम आइडेंटिकल एफिशिएंसी. तो बहुत सिंपल है सर जी. देखो, व्हाट इज द एफिशिएंसी, ये कौन सा इंजन है एक बार देख लो सर. कार्नॉट है, कार्नॉट इज रिवर्सिबल. तो अगर ये कार्नॉट है तो मेरे प्यारे दोस्तों, आई कैन राइट एफिशिएंसी इन टर्म्स ऑफ टेम्परेचर्स. तो व्हाट इज द एफिशिएंसी ऑफ 1 minus T lower. तो इस के लिए the lower is T and T higher is TH. And what is the efficiency of 2? ये वाला. For this is higher, this is lower. इसके लिए ये higher, ये lower है. तो 1 minus T lower is this and T higher is T. ध्यान से सुनो सर. For this engine, इसके लिए ये higher, 1 minus T lower is this and higher is TH. और इसके लिए the lower is this, higher is 1 minus T lower by T higher is this. He said same efficiency. तो क्या करेंगे सर? 1 कट जाएगा, माइनस कट जाएगा, तो T by TH is equal to TL by T. So T square is equal to TH TL. He is asking T value. It will be under root of, याद रखना, whenever efficiencies are same, the intermediate temperature will be geometric mean. When the works are same, करेंगे सर. It will be arithmetic mean. क्या पता ये आ सकता है. We can derive. The higher temperature is 1600 given and the lower is 400 given. So therefore दो zeros means एक zero आएगा. 64 हाँ, ये दो zeros मतलब दो zeros, ये 1 2 3 4. 64 का मतलब क्या है? रूट 64 कितना होगा सर? 8. So it will be 800 Kelvin, sir. So the answer is 800 Kelvin. Answer is 800. He is asking in Kelvin. Last two questions. मित्रों ये करो. अच्छा क्वेश्चन है सर. 0th लॉ का ये क्वेश्चन. मेक इट फास्ट. A particular temperature is obtained according to the relation, okay, where T is in degree centigrade, alpha is क्या बोलते हैं प्रॉपर्टी, द थर्मोमेट्रिक प्रॉपर्टी इज मेजर्ड बाय अल्फा इज सम थर्मोमेट्रिक प्रॉपर्टी. ठीक है. द वैल्यू ऑफ अल्फा एट आइस पॉइंट. ओके ओके. इक्वेशन क्या दिया सर? T इज इक्वल टू ए ई पावर अल्फा प्लस बी. ठीक है सर. The values of alpha are, ice point is 0 डिग्री सेंटीग्रेड. जब ये आइस पॉइंट पे है तो अल्फा का वैल्यू क्या है सर? आइस पॉइंट एंड स्टीम पॉइंट आर 6 and 9. स्टीम पॉइंट का मतलब 100 डिग्री सेंटीग्रेड. तो व्हाट इज द वैल्यू ऑफ अल्फा गिवन? 9. एंड ही इज आस्किंग व्हाट इज द टेम्परेचर व्हेन द थर्मोमेट्रिक प्रॉपर्टी इज 7. ये पूछा सर. बहुत सिंपल. टू कॉन्स्टेंट्स कैसे करेंगे सर? टू कॉन्स्टेंट्स है तो टू इक्वेशंस कंसिडर करना, टू अननोन्स वी कैन सॉल्व. देखो एक सेकंड. T1 इज इक्वल टू ए ई अल्फा 1 प्लस बी, बिकॉज ए बी कॉन्स्टेंट है. व्हाट इज T1? 0. इट इज इन डिग्री सेंटीग्रेड. ए ई पावर व्हाट इज अल्फा 1 सर? अल्फा 1 इज 6 प्लस बी. ये पहला इक्वेशन है. नेक्स्ट T2 इज इक्वल टू, this is the equation number 1. T2 is equal to AE alpha 2 plus B. What is T2 sir? T2 is 100. AE alpha 2 is 9 plus B. So this is my second equation. This is the first. AE power 6 ये आ गया. दो equations, दो unknowns I can easily solve. So अगर हम solve करते हैं, पता नहीं यार ये कहाँ गए. Which I think I have calculated, but I don't know where I calculated. ढूंढना पड़ता है सर. अल्लाह. लेट मी चेक सर. एक बार मैं चेक कर लेता हूँ. मेरा ही कैलकुलेटेड पता नहीं मिल रहा है. समवेयर आई थॉट कि आई शुड नॉट वेस्ट टाइम, इसीलिए मैं पहले ही कैलकुलेट करके रखा सर. नहीं मिल रहा है सर. 1 सेकंड प्लीज. अरे यार. है सर जी. ए का वैल्यू, ये दो इक्वेशन से ए का वैल्यू आ रहा है 0.012987567 एंड बी का वैल्यू आ रहा है -5.24. वेरी गुड. पुट वैल्यूज ऑफ ए एंड बी हियर. तो इधर पुट करना. तो टी विल बी इक्वल टू ए 0.0. अरे दीज टू इक्वेशंस आप आराम से सॉल्व कर सकते सर. b इज इक्वल टू माइनस ए ई पावर 6. तो b इज इक्वल टू माइनस ए पावर ए को कॉमन लेना, ई पावर 9 माइनस ई पावर 6 आराम से कैलकुलेट करेंगे. तो 0.012987567 ए ई पावर अल्फा प्लस b इज 5.24. तो यहां से आई कैन इजिली कैलकुलेट. अल्फा का वैल्यू 7 दिया है सर. आई थिंक अल्फा 7. तो पुट अल्फा इज इक्वल टू 7. तो अल्फा को 7 पुट करना सर. इफ यू पुट अल्फा 7 एंड यू विल गेट द वैल्यू ऑफ टेम्परेचर. तो ई पावर 7 तो कितना होगा सर? यू नो इसमें पुट करना. ए वैल्यू इज नोन. ई पावर अल्फा इज अल्फा 7 दिया है. एट 7 ही इज आस्किंग द टेम्परेचर एंड बी इज माइनस. तो यहां से टेम्परेचर आएगा आई थिंक 9 डिग्री. रफली 9 डिग्री आ रहा है सर. आई थिंक रफली इट इज 9. चेक करता हूं सर मित्रों. यस 9 इज करेक्ट. लास्ट क्वेश्चन. लास्ट क्वेश्चन. लास्ट क्वेश्चन. इन ए पिस्टन सिलेंडर असेंबली मतलब क्लोज्ड सिस्टम, 1 kilomole, मोल में दिया है, of an ideal gas from initial state, initial pressure is 200 and the initial temperature is 400 to a final state of 1 megapascal and the final temperature is 400 Kelvin. If the surroundings are at 400, the minimum amount of work required for compression. आप जानते हैं सर, the minimum work of compression, ये तो closed system है because it's a piston cylinder arrangement. So minimum work of compression will be, अगर आप plot करेंगे मित्रों, this is constant pressure, तो the index is equal to 0 and this is constant volume, index is infinity. तो अगर कंप्रेस करते जा रहे हैं तो K का वैल्यू बढ़ते जा रहा है. N is 1 isothermal, N is then gamma. तो मिनिमम वर्क होगा आपका किसमें होगा सर? आइसोथर्मल में होगा सर. So minimum work will be for isothermal. Minimum work will be for isothermal. So therefore, एक सेकंड, तो let's calculate the minimum work बोला है, तो work input will be minimum for isothermal. What is the physical explanation for this? Okay. कहां गया रे वो? तो it will be N, कहां गया? N R bar T ln P2 by P1. ना. ln R bar T V2 by V1. V2 by V1. Correct. And you know, for isothermal process, as it is a rectangular hyperbola, closed system work for an ideal gas is also equal to open system work. So कोई problem नहीं सर. Whenever देखो isothermal process के लिए, as it is a rectangular hyperbola, closed system work and open system works are same because a rectangular hyperbola is symmetric about x and y axis. When you project it on volume axis or pressure axis, it will give me the same answer. So N per kilomole बोला तो N1, R bar is 8.314 and the temperature is 400 and ln V2 by V1. मेरे प्यारे दोस्तों प्रेशर्स दिया है, तो आइसोथर्मल के लिए बिकॉज टेम्परेचर तो यहां पे कांस्टेंट है 400, तो PV इज इक्वल टू MRT. मास इज कांस्टेंट, R इज कांस्टेंट, टेम्परेचर इज कांस्टेंट. आइसोथर्मल PV इज कांस्टेंट, P1 V1 इज इक्वल टू P2 V2. सो V2 by V1 is equal to P1 by P2. So therefore it is P1, V2 by V1 can be written as P1 by P2. The initial pressure is 200 and the final pressure, देखो kilopascal, this should also be in kilopascal. तो 1 megapascal is 1000 kilopascal. तो ये हो जाएगा आपका कितना आ रहा है सर? Why are you taking NR bar? Because he is asking in mole. ln 200 by, next time onwards I'll calculate all the values and keep ready not to waste your time. फिर भी हम बहुत स्टेडी पेस पे किए सर. तो 5352 किलोजूल पर किलोमोल. बट देखिए माइनस आंसर नहीं देना चाहिए सर. द रीजन इज आस्किंग कंप्रेशन वर्क. कंप्रेशन इटसेल्फ इज नेगेटिव वर्क, सो द आंसर माइनस ड्रॉप कीजिए सर. यू शुड, इट इज NAT क्वेश्चन, तो इट विल बी 5352. द आंसर इज 5352. लेट मी राइट 5352 बिकॉज he already asked compression work 5352. So I tried my level best to solve. देखो, the beauty is in just 2 hours 22 questions are discussed in detailed manner. So next I am planning with SOM and thermo SOM करते हुए, तो GATE 2026 के लिए I'll take some marathon sessions and I'll try to help you out. Okay, so we are starting our new batches in February after the GATE examination and we are coming up with a systematic plan. Okay, we are not in hurry, so we are running our own race. Hope you enjoyed this. So after the class, please share your views in the form of comments. कैसा लगा? Because I have not wasted your time. Okay, thank you. Goodbye.